Hello, Namaskar, Ellarigu. I welcome you all to the Vedantu Karnataka. ನಾನು master teacher Rithika. So, ಇವತ್ತಿನ topic ಯಾವ್ದಪ್ಪ? Chemical bonding, which is actually a first PUC topic. ಆಯ್ತಾ? So, ನೀವು ನೋಡಿರಬಹುದು already we have started with the NEET classes, that is one shot. So, ಇವತ್ತಿನ topic ಯಾಕಪ್ಪ ಅದನ್ನ ತಗೊಂಡಿದ್ದೇನೆ. Okay. Just give me 1 second, guys. PUC topic, right? So you know about already we have started with the NEET classes, that is one shot. So within topic, okay, am I audible properly now? I think double sounding ಆಗ್ತಿತ್ತು. I think still it's happening. Just give me 1 second, guys. No, it's not that. Okay, just wait for 2 minutes, okay? It's coming, it's coming. Yes, I'm audible now? I'm audible now? Just confirm yes in the thumbs up in the chat box fast. Okay, just wait for 2 minutes, okay? Let's try. Okay, then let's start the class. So today's topic is chemical bonding. Yes, I'm audible. That's good. That's good. Okay. Okay. So ಇವತ್ತಿನ topic ಯಾವುದು? Chemical bonding. So NEET chapter already we have started with the NEET, right? So ಈಗ NEET chapters ಯಾವ್ಯಾವ ಟಾಪಿಕ್ಸ್ ಮುಗ್ದಿದೆ ಅಲ್ಲ ಆಲ್ರೆಡಿ ಬಸವ ಸರ್ ಮತ್ತೆ ಗೋಪಿಕಾ ಮ್ಯಾಮ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದಾರೆ, ರೈಟ್? ಸೊ ಇವತ್ತಿಂದು ಕೆಮಿಸ್ಟ್ರಿದು ಐ ಥಿಂಕ್ ಇಟ್ ಇಸ್ ಅ ಫಸ್ಟ್ ಚಾಪ್ಟರ್. Okay, it's a chemistry's first chapter. Yes, I'm audible. Yes. Hi everyone. So first of all I want to wish everyone the happy Diwali. So in case ನಾನು previously ಯಾವ ಕ್ಲಾಸ್ ತಗೊಂಡಿಲ್ಲಲ್ಲ ಅದಕ್ಕೆ ನಾನು ಸ್ವಲ್ಪ ದಿವಾಲಿ ಸೆಲೆಬ್ರೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗಿದ್ದೆ. So happy Diwali to everyone. Hope so everyone have enjoyed your holidays of the Diwali. ಯಾಕಂದ್ರೆ ಮಿಡ್ ಟರ್ಮ್ ಎಕ್ಸಾಮ್ಸ್ ಅಂತೂ ಬಂದಿತ್ತು. ಮಿಡ್ ಟರ್ಮ್ ಎಕ್ಸಾಮ್ಸ್ ಬಂದ ತಕ್ಷಣನೇ ದಿವಾಲಿ ಇತ್ತು. ಸೊ ಮೋಸ್ಟ್ ಆಫ್ ದ ಸ್ಟೂಡೆಂಟ್ಸ್ ಆರ್ ಲೈಕ್ ಫುಲ್ ರೆಸ್ಟ್ ಆಗಿಬಿಡ್ತು ಮ್ಯಾಮ್. ಸೊ ಅದಕ್ಕೆ ರೆಸ್ಟ್ ಮಾಡಿಬಿಟ್ರಿ. ಈಗ ಕ್ಲಾಸ್ ಅನ್ನು ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಲೇಬೇಕು. ಬಿಕಾಸ್ ಯಾವ ತರ ನೀವು ಏನ್ ಮಿಡ್ ಟರ್ಮ್ ಎಕ್ಸಾಮ್ಸ್ ಅನ್ನ ಬರ್ದಿದಾರೋ ಅದ್ರ ಮೇಲೆ ನಿಮಗೆ ರಿಯಾಲಿಟಿ ಚೆಕ್ ಗೊತ್ತಾಗಿರುತ್ತೆ ಆಲ್ರೆಡಿ. ಯಾವ ತರ ನೀವು ಪೇಪರ್ಸ್ ಅನ್ನ ಬಂದಿದಾರ ಅನ್ನೋದು. ಈಗಾದ್ರೂ ನೀವು ಸೀರಿಯಸ್ ಆಗ್ಲೇಬೇಕು. ಯಾರಾದ್ರೂ ಪ್ರಿಪೇರ್ ಆಗ್ತಿದ್ರೆ ನೀಟ್ ಎಕ್ಸಾಮ್ಸ್ಗೆ, ಯು ಪೀಪಲ್ ಕ್ಯಾನ್ ವಾಚ್ ದಿಸ್ ಒನ್ ಶಾರ್ಟ್ಸ್. ಇಟ್ ವಿಲ್ ರಿಯಲಿ ಹೆಲ್ಪ್ ಯು ಪೀಪಲ್. ಸೊ ನನಗೆ ಗೊತ್ತು ನೀಟ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಅಂದ್ರೆ ಆಲ್ರೆಡಿ ನೀವು ಫುಲ್ ಚಾಪ್ಟರ್ಸ್ ನೋಡಿರ್ತೀರಾ. ಸೊ ದಿಸ್ ಮೈಟ್ ಹೆಲ್ಪ್ ಯು ಟು ಡೂ ದ ರಿವಿಷನ್ ಆಲ್ಸೋ ಪ್ರಾಪರ್ಲಿ. ಓಕೆ, ಸೊ ಆಲ್ಮೋಸ್ಟ್ ಎಲ್ಲರೂ ಕವರ್ ಮಾಡ್ಕೊಂಡಿರ್ತಾರ ನೀಟ್ ಸ್ಟೂಡೆಂಟ್ಸು ಎಲ್ಲ ಚಾಪ್ಟರ್ಸ್ ಅನ್ನ. ಸೊ ಇನ್ ಕೇಸ್ ಹಾಗೆ ಬರೀತಿದ್ರೆ ಅಂದ್ರೆ ನೀವು ಪೀಪಲ್ ಕ್ಯಾನ್ ವಾಚ್ ದಿಸ್ ವಿಡಿಯೋ ಫಾರ್ ದ ರಿವಿಷನ್ ಪರ್ಪಸ್ ಆಲ್ಸೋ. ಓಕೆ. Oh, thank you. Why? You don't want me to start at 5 o'clock, huh? It's good, no, that I started at 5 o'clock. Okay, then. Let's start. Let's start then. Yes. ಸೊ ಇವತ್ತಿನ ಏನಂದ್ರೆ ಫಸ್ಟ್ ನಿಮ್ಗೆ ಹೇಳ್ತೇನೆ ಯಾವ ತರ ಟೈಪ್ ಆಫ್ ಕ್ವಶನ್ಸ್ ಕೇಳ್ಬಹುದು ಈ ಚಾಪ್ಟರ್ ಇಂದ ಅನ್ನೋದು ನಿಮಗೆ ಇನ್ಫಾರ್ಮೇಶನ್ ಕೊಡ್ತೇನೆ. ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಆಕ್ಚುಲಿ ದೇ ವಿಲ್ ಆಸ್ಕ್ ಆಲ್ಮೋಸ್ಟ್ ಓಕೆ 3 to 4 questions from this chapter. 3 to 4 questions from this chapter and the marks will be from almost 12 to 14 marks. ಓಕೆ, ಸೊ 3 to 4 ಕ್ವಶನ್ಸ್ ಕೇಳ್ಬೋದು ಈ ಚಾಪ್ಟರ್ ಇಂದ. ಸೊ ಮಾರ್ಕ್ಸ್ ಟೋಟಲಿ ಬರಬಹುದು ಯಾವುದು 12 to 14 ಮಾರ್ಕ್ಸ್ ಬರಬಹುದು. ಓಕೆ, ಸೊ 12 to 14 ಮಾರ್ಕ್ಸ್ ಬಂದ್ರೆ ಬರಬಹುದು. ಸೊ ಟುಡೇ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲರ್ನ್ ಯಾಕಪ್ಪ ಈ ಚಾಪ್ಟರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ ಅನ್ನೋದು ಫಸ್ಟ್ ಹೇಳ್ತೇನೆ. ಬಿಕಾಸ್ ಈ ಟಾಪಿಕ್ ಇಂದ ಜಾಸ್ತಿ ಅಂದ್ರೂ 4 ಕ್ವಶನ್ಗಿಂತ ಜಾಸ್ತಿ ಕೇಳಿದ್ದಾರೆ. Okay, means you can just imagine in 720 marks of NEET. So ಅಷ್ಟು ಟೋಟಲ್ ಮಾರ್ಕ್ಸ್ ನಲ್ಲಿ ಇದು 7% ಅಂತ ತಿಳ್ಕೊಂಬಿಡಿ. ಓಕೆ, ಈ ಚಾಪ್ಟರ್ ಇಂದ 7% to 100% ಶೋರ್ ಬಿದ್ದೇ ಬೀಳುತ್ತೆ. ಸೊ ಮೇಕ್ ಶೋರ್ ಯು ಪೀಪಲ್ ವಿಲ್ ನಾಟ್ ಸ್ಕಿಪ್ ದಿಸ್ ಚಾಪ್ಟರ್. ಓಕೆ, ಬಿಕಾಸ್ ಹೈಯೆಸ್ಟ್ ವೇಟೇಜ್ ಅದು ಫಸ್ಟ್ PUC ಚಾಪ್ಟರ್ ನಲ್ಲಿ, ಆಯ್ತಾ? ಸೊ ಲೆಟ್ ಸ್ಟಾರ್ಟ್. ನಾನು ಯಾವ ತರ ಕಲಿಸ್ತಿದ್ದೇನೆ ಇವತ್ತು ಹೇಳ್ತೇನೆ. ಸೊ ಫಸ್ಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡೂ ವಿತ್ ದ NCERT ಆಲ್ಸೋ. ನಾನು NCERT ಸ್ನಿಪ್ಸ್ ತಗೊಂಡಿದ್ದೇನೆ. ಸೊ those also I'm going to teach you people line to line. Plus I have made some few points also. So adunnu kalistene easy agi so that you will understand it clearly. Because ಜಾಸ್ತಿ ಜನ ಏನು ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ NCERT ಬುಕ್ ತಗೊಂಡು ಚೆನ್ನಾಗಿ ಕುಂತು ನೋಟ್ಸ್ ಮಾಡ್ತಾರೆ. ಸೊ ದಟ್ ವಿಲ್ ಹೆಲ್ಪ್ ಸಮ್ ಸ್ಟೂಡೆಂಟ್ಸ್. ಓಕೆ, ಸೊ ಇವತ್ತು ಅದಕ್ಕೆ ನಾನು 2 ತರ ನೋಟ್ಸ್ ನ ತಗೊಂಡು ಬಂದಿದ್ದೇನೆ. ಸೊ ದಟ್ ಇಟ್ ವಿಲ್ ರಿಯಲಿ ಹೆಲ್ಪ್ ಯು ಪೀಪಲ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಕಾನ್ಸೆಪ್ಟ್ ಪ್ರಾಪರ್ಲಿ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಫ್ಯೂ ಈಸಿ ಟಾಪಿಕ್ಸ್ ಆಲ್ಸೋ. ಫ್ಯೂ ಈಸಿ ಎಕ್ಸಾಂಪಲ್ಸ್ ಅನ್ನು ತಗೊಂಡಿದ್ದೇನೆ. ಆ ತರ ನಮಗೆ ಈಸಿ ಆಗುತ್ತೆ ಚಾಪ್ಟರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಲಿಕ್ಕೆ. Okay, so I want everyone to be very active in the channel right now. Everyone needs to be commenting in the comment box that whether you are understanding the concept clearly or no. Clear? So who has not marked your attendance till Fast ಆಗಿ attendance mark ಮಾಡಿ. So I want to see how many people are going to mark your attendance right now. So 50 ಅಂತೂ cross ಆಗಲೇಬೇಕು ಆಯ್ತಾ. 50 likes before I end the session, it should be there. ಇಲ್ಲಾಂದ್ರೆ ರಿತಿಕಾ ಮ್ಯಾಮ್ ಜೋಶ್ ಹೆಂಗ್ ಬರೋದು, ರೈಟ್? ಸೊ ಅದಕ್ಕೆ ಫಾಸ್ಟ್ ಆಗಿ ಮಾಡಿ. ಇನ್ ಕೇಸ್ ಯಾರಾದರೂ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಟು ದ ಚಾನಲ್ ಆಲ್ಸೋ. ಕ್ಲಿಯರ್? ಲೆಟ್ಸ್ ಸ್ಟಾರ್ಟ್. First is about the introduction of the chemical bond. So chemical bond is the attractive force which holds the various consistencies together in a molecule. Means chemical bond andre enu, ಈಗ ಯಾವುದಾದರೂ two elements ತಗೊಂಡಿದ್ದೀರಪ್ಪ, okay? You have taken two elements. In that two elements, how it's got bonded together, okay? ಯಾವ ತರ ಇದು ಬಾಂಡ್ ಆಗಿದೆ ಎರಡು ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ಅದನ್ನ ನೀವು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೇಕು ಆಯ್ತಾ. ಸೊ ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್, ದೇರ್ ಆರ್ ಆಲ್ಮೋಸ್ಟ್ 3 types of chemical bonds. First is going to be the ionic bond, then the covalent bond, then the coordination bond. ಸೊ ಈ ಮೂರು ಟಾಪಿಕ್ ಅನ್ನ ಚೆನ್ನಾಗಿ ಕೊಂಡು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೇಕು. ವಾವ್, ಚಿನ್ನಿ is full in strong way to understand the chapter today, right? Hi Tarun. ಓಕೆ, ಸೊ ಇವತ್ತು ಫಸ್ಟ್ ಕೆಮಿಕಲ್ ಬಾಂಡ್ ಏನು ಮತ್ತೆ ಅದರ ಬಾಂಡ್ಸ್ ಏನಪ್ಪಾ ಅಂತ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳೋಣ ಆಯ್ತಾ. ಸೊ ಹಿಯರ್ ಕೆಮಿಕಲ್ ಬಾಂಡ್ ನಲ್ಲಿ 3 ಟೈಪ್ಸ್ ಇದೆ. ಅಯೋನಿಕ್ ಬಾಂಡು, ಕೋವಲೆಂಟ್ ಬಾಂಡು ಮತ್ತೆ ಕೋಆರ್ಡಿನೇಷನ್ ಬಾಂಡು. ಈ ಮೂರು ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅನ್ನ ನೀವು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡು ಮುಂದೆ ಫ್ಯೂಚರ್ ನಲ್ಲಿ ಚಾಪ್ಟರ್ಸ್ ನಿಮಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗೋದು ಆಯ್ತಾ. ಸೊ ಈ ಮೂರು ಬಾಂಡು ಪರ್ಫೆಕ್ಟ್ ಇದ್ರೆ ಡೆಫಿನೇಷನ್ಸ್ ಯಾವ ತರ ಬಾಂಡ್ಸ್ ಅನ್ನ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಅವೆಲ್ಲ ಪರ್ಫೆಕ್ಟ್ ಇದ್ರೆ ನೀವು ಆರಾಮಾಗಿ ಆರ್ಗ್ಯಾನಿಕ್, ಇನ್ಆರ್ಗ್ಯಾನಿಕ್, ಫಿಸಿಕಲ್ ಎಲ್ಲ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತೆ ಆಯ್ತಾ. ಸೊ ನಾವ್ ಎವ್ರಿವನ್ ನೀಡ್ ಟು ಟೆಲ್ ಮಿ ವಾಟ್ ಈಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ಅನ್ ಅಯೋನಿಕ್ ಬಾಂಡ್. ನಾಟ್ ಎಲ್ಸ್ ಯು ಪೀಪಲ್ ಜಸ್ಟ್ ಆನ್ಸರ್ ಮಿ ಒನ್ ಕ್ವಶನ್. ಅಯೋನಿಕ್ ಬಾಂಡ್ ಸ್ಟ್ರಾಂಗ್ ಇದೆನೋ, ಕೋವಲೆಂಟ್ ಬಾಂಡ್ ಸ್ಟ್ರಾಂಗ್ ಇದೆನೋ, ಕೋಆರ್ಡಿನೇಷನ್ ಬಾಂಡ್ ಸ್ಟ್ರಾಂಗ್ ಇದೆ, ಯಾವ್ದು ಅಪ್ಪ ಸ್ಟ್ರಾಂಗ್ ಇದೆ? ಫಸ್ಟ್ ಕಮೆಂಟ್ ಬಾಕ್ಸ್ ನಲ್ಲಿ ಎಲ್ಲರೂ ಆನ್ಸರ್ ಮಾಡಿ ನೋಡೋಣ. ಯಾವ್ದಪ್ಪ ಸ್ಟ್ರಾಂಗ್ ಇದೆ? ಎಲ್ಲಕ್ಕಿಂತ ಸ್ಟ್ರಾಂಗೆಸ್ಟ್ ಒನ್ ಇಸ್ ವಿಚ್? ಫಸ್ಟ್, which is the strongest one in this? So ಈ ಮೂರು ಬಾಂಡ್ಸ್ ನಲ್ಲಿ which is the strongest one? ಸೊ ಈ ಕ್ವೆಶ್ಚನ್ ಎಂಡ್ ಆಗಿ ನೀವೇ ಆನ್ಸರ್ ಮಾಡ್ತೀರಾ if you people will stay with me till I end the session ಆಯ್ತಾ. ಸೊ ಎಲ್ಲರೂ ಹೇಳ್ತಿದ್ದಾರೆ ionic bond. Yes, let's see that after learning this chapter whether the ionic bond is the strongest one or no. Okay, so first comes the Lewis symbol. So let us understand what is the meaning of a Lewis symbol now. Okay, now in the formation of a molecule only the outer shell electrons take part in a chemical combination. Outermost, so outer part ಅಂದ್ರೆ ಏನು? example ಹೇಳ್ತೇನೆ. Okay, this is actually your okay ನಿಮ್ದು ಇದು ನ್ಯೂಕ್ಲಿಯಸ್ ತಿಳ್ಕೊಳ್ಳಿ ಆಯ್ತಾ. So then afterwards this is our K shell, done. This is our L shell, done. This is our L shell, KL, M ಆಯ್ತು ತಿಳ್ಕೊಳ್ಳಿ ಆಯ್ತಾ. M shell ತಗೊಂಡ್ವಿ, right? So now you people need to understand here, ಇದು ನ್ಯೂಕ್ಲಿಯಸ್, right? This is K shell, this is L shell and this is M shell. Now ಈ KLMN ನಲ್ಲಿ ಆ ಸ್ಥಿತಿನಲ್ಲಿ ಯಾವ್ದು outermost shell ಇದೆ? M is outermost shell right now, right? Outermost shell. ಸೊ ಈ outermost shell ಏನಿದೆ ಅಲ್ಲ ಅದು ಅಷ್ಟೇ ಪಾರ್ಟಿಸಿಪೇಟ್ ಮಾಡೋದು, ಅದು ಒಂದೇ ಪಾರ್ಟಿಸಿಪೇಟ್ ಮಾಡೋದು. ಎದ್ರಲ್ಲಿ ಪಾರ್ಟಿಸಿಪೇಟ್ ಮಾಡುತ್ತೆ? ಇನ್ ದ ಲಿವಿಸ್ ಸಿಂಬಾಲ್ ಫಾರ್ ಬಾಂಡಿಂಗ್ ಪರ್ಪಸ್. ಓಕೆ, ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ outermost shell ನಲ್ಲಿ ಇದೆ ಅಲ್ಲ ಅದಕ್ಕಂತೂ ಏನ್ ಕರೀತಾರೆ? ವೇಲೆನ್ಸಿ ಅಂತ ಕರೀತಾರೆ, ನಿಮಗೆ ಗೊತ್ತಿದೆ, ರೈಟ್? ಸೊ ನಾವು how you people need to understand by this concept about the Lewis symbol. Now in the formation of the molecules only the outermost shell of the electrons are going to be participating. Only the outermost shell of the electron will be participating. Okay, now combination and they are known as valence electrons, that is outermost shell ನಲ್ಲಿ in case ಎರಡು electrons ಇದೆ ಅಂದ್ರೆ ಅದರದ್ದು ಏನಪ್ಪ valency? ಎರಡು ಆಯ್ತಾ. Now the inner shell electrons are the well protected and are generally not involved in the combination process. So because of that, this G.N. Lewis, who was the scientist who introduced that thing, so that person what he did is an American chemist introduced the simple notation to represent the valence electrons in an atom. So understand about the valence electrons. So how it's helping to bond the things. Okay, these notations are called as what? Lewis symbols. And for examples, the Lewis symbols are the elements of second period are under things means how you need to understand. Like example, lithium. Lithium nalli outermost shell yaudappa, one electron ide, so we have put it as one dot. Means what? Lewis dot structure idu. Okay, ಈಗ lithium ಯಾವ್ದಾದ್ರು dot structure ಬತ್ತಾಗಿರಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ ಏನಾಗುತ್ತಪ್ಪ, one dot ತೆಗಿಬೇಕು, because at its outermost shell it has only one electron. So at its outermost shell it has only one electron. Am I right? Fast thumbs up haki idrnalli comment box nalli fast. So next comes what? For example, we will take it as beryllium, that is B, it is having outermost shell as a 2 electrons. So then afterwards boron, that is having 3. Next comes the carbon, that is having 4. Then comes the nitrogen, oxygen, fluorine, neon. Now easy way to how to put it. ಹೇಗಪ್ಪ ಹಾಕೋದನ್ನ? ಎಕ್ಸಾಂಪಲ್ ಕಾರ್ಬನ್ ಇದೆ. ಫಸ್ಟ್ ಕಾರ್ಬನ್ ನಲ್ಲಿ 4 electrons ಇದೆ outer most shell ನಲ್ಲಿ, ಆಯ್ತಾ? So first what we are going to do, first what we are simple thing is, one electron ಇಲ್ಲಿ ಹಾಕಿದ್ವಿ dot structure ನಲ್ಲಿ, ಇನ್ನೊಂದಿಲ್ಲಿ, ಇನ್ನೊಂದಿಲ್ಲಿ. So ಈ ತರ ಮಾಡಬೇಕು, ಆಯ್ತಾ? Next comes, let us take the neon as an example. Okay, neon example ತಗೊಳ್ಳೋಣ. So ಈ neon ನಲ್ಲಿ ಎಷ್ಟಿದೆ ಅಪ್ಪ? 1. outermost shell ಅಲ್ಲಿ ಎಲ್ಲಿದೆ? 8 ಇದೆ, right? So 1 2 3 4. Done. Next 1 2 3 4. Done. So in this way you people need to draw the structures. Clear? You need to draw the structures. This is the easy way to understand about the Lewis dot structure. These are all the examples for the Lewis dot structures. Aita? Next one. Now here you need to understand about the Kozil in relation to the chemical bonding drew attention to the following facts. What he actually did it means ಯಾವ ತರ ಅವನಿಗೆ ಐಡಿಯಾ ಬಂತು ಲಿವಸ್ ಬಗ್ಗೆ, ಯಾವ ತರ ಡಾಟ್ ಸ್ಟ್ರಕ್ಚರ್ ಬಗ್ಗೆ ಐಡಿಯಾ ಬಂತು ಅದನ್ನ ತಿಳ್ಕೊಳ್ಳೋಣ, ಆಯ್ತಾ? ಸೊ ದಿಸ್ ಇಸ್ ಅಬೌಟ್ ಯುವರ್ NCERT ಬುಕ್ ಇಟ್ ಸೆಲ್ಫ್. ಸೊ ಅದನ್ನು ಕಲಿಸ್ತಿದ್ದಾನೆ, ಸೊ ದಟ್ ವಿಲ್ ಹೆಲ್ಪ್ ಯು ಪೀಪಲ್ ಫಾರ್ ದ ಥಿಯರಿ ಆಲ್ಸೋ, ಆಯ್ತಾ? So first point is what? In the periodic table, the highly electronegative halogens and the highly electropositive alkali metals are separated by the noble gases. So in the periodic table, we all know the metals are different, non-metals are different, and the noble gases are a different way. So noble gases andre nanu ಏನು ಹೇಳಿದೆ, every class ನಲ್ಲಿ ನಾ ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೆ, noble gases ಅಂದ್ರೆ ಏನಪ್ಪ? They all are Ambanis. Okay, so noble gases ಅಂದ್ರೆ ಅಂಬಾನಿ ಫ್ಯಾಮಿಲಿ ಅಂತ ತಿಳ್ಕೋಬೇಕು, ಬಿಕಾಸ್ ಇವ್ರ ಕಡೆ ಎಲ್ಲ ಇದೆ, ಅವ್ರಂತೂ ಬಂದು ನಮ್ಮ ಪಾರ್ಟಿಸಿಪೇಟ್ ಎದ್ರಲ್ಲೇನು ಮಾಡಲ್ಲ. So they are only actually giving us the money to survive actually. Okay, so adar salvagi one simple thing tilkonbidona, periodic table nalli noble gases andre Ambanis appa. Okay, remaining who are there? They are surviving, means they are trying to survive by earning. Like example, I will take this electron, I'll gain more money, I'll give the electron, I might lose the money. So ee tara family naditide living the noble gas, aita? So now second is what? The formation of the negative ion from the halogen atom and the positive ion from the alkali metal. Okay, so yav tara agutte? The formation of negative ion. Okay, negative ion andre ಏನು ತಿಳ್ಕೋಬೇಕು? So negative ion means what? Negative ion will form the halogen atom. So formation of a negative ion from the halogen atom and the positive ion from the alkali metal. Okay, ಪಾಸಿಟಿವ್ ಅಯಾನ್ ಅಂದ್ರೆ ಏನು? ಆಲ್ಕಲಿ ಮೆಟಲ್. ಶಾರ್ಟ್ ಫಾರ್ಮ್ ಆಗಿ ಹೇಳ್ತಿದೆ ನಿಮಗೆ, ಈಸ್ ಅಸೋಸಿಯೇಟೆಡ್ ವಿತ್ ದ ಗೇನ್ ಆರ್ ಅ ಲಾಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬೈ ದ ರೆಸ್ಪೆಕ್ಟಿವ್ ಆಟಮ್ಸ್. ಲೈಕ್ ವಾಟ್? ಇಫ್ ದ ಪಾಸಿಟಿವ್ ಸೈನ್ ಇಸ್ ದೇರ್ ಮೀನ್ಸ್ ವಾಟ್? ಐ ಆಮ್ ಗಿವಿಂಗ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಟು ಸಮ್ ಒನ್. ನನ್ನ ತಲೆ ಮೇಲೆ ಪಾಸಿಟಿವ್ ಇದ್ರೆ ನಾನು ಯಾರಿಗೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕೊಡ್ತಿದ್ದೇನೆ, ಆಯ್ತಾ? ಸೊ ಇನ್ ಕೇಸ್ ಐ ಆಮ್ ಗಿವಿಂಗ್, ಟೇಕಿಂಗ್ ದ ಎಲೆಕ್ಟ್ರಾನ್, ನಾನು ಯಾರ ಕಡೆಂದು ಇಸ್ಕೋತಿದ್ದೇನೆ ಎಲೆಕ್ಟ್ರಾನ್ ಅಂದ್ರೆ ನನ್ನ ತಲೆ ಮೇಲೆ ನೆಗೆಟಿವ್ ಸೈನ್ ಇರುತ್ತೆ, ಆಯ್ತಾ? ಸೊ ದಿಸ್ ಇಸ್ ವೆರಿ ಸಿಂಪಲ್ ಟು understand. Now the negative and the positive ions thus formed are attain the stable noble gas electronic configuration, and the noble gas with the exception of helium, which has the duplet of the electrons, have a particularly stable outermost shell configuration, and it, that is octet electrons, is going to be what? ns2np6. It means what? So it means like electronic configuration complete ಮಾಡ್ತಿದೆ. I want to be satisfied, I want to act like an Ambani. ನನಗೂ ರಿಚ್ ಆಗೋದಿದೆಯಪ್ಪ. ಸೊ ರಿಚ್ ಆಗೋ ಸಲುವಾಗಿ ನಾವೆಲ್ಲರೂ ಕೆಲಸ ಮಾಡ್ತಿದ್ದೇವೆ. ನೀವೆಲ್ಲ ಓದೋದು ಎದಕ್ಕೆ? Why you people are learning? You people are learning to become rich, right? So ಎಲ್ಲರಿಗೆ ರಿಚ್ ಆಗೋದಿದೆ. ಸೊ ನಾನು ಅದಕ್ಕೆ ಈಗ ಕಲಿಸ್ತಿದ್ದೆ ನಿಮಗೆ, right? So everyone wants to be rich. So this electronic configuration is going to change according to they want to be like a Ambani. According to that, they will start preparing the electronic configuration. Like what? ನೀನು ಒಂದು ಸ್ವಲ್ಪ ತಗೋ, ನಾನು ಒಂದು ಸ್ವಲ್ಪ ತಗೋತೇನೆ, and I'll be happy, like that. Okay. Next, the negative and the positive ions are stabilized by the electronic attraction. Example, okay, formation of NaCl from the sodium and chloride according to the above scheme is Na, which is actually giving the electron to someone. It's giving the electron to someone. Understanding? Yes. Next comes the neon, that is also giving some electrons to someone. Chloride, neon. So in this way you need to understand that some electrons has been given, that is going to be positive. Some electrons are going to be taken, that is going to be the negative one. Clear? Next comes the bond formed as a result of the electrostatic attraction between the positive and the negative ions was termed as the electrovalent bond. It is termed as what? Electrovalent bond. And the electrovalence is thus equal to the number of unit charge on the ion. Number of the unit charge on the ion. Clear? Now, thus the calcium is assigned as a positive electrovalence of the 2, while the chlorine is a negative electrovalence of the 1. Like example, chlorine is actually taking the electrons to become stable. Okay, it's becoming stable by taking the electron from someone. But here the calcium is actually assigned to what? It's actually giving the electron to someone to take it. Means, ಈ example ತಿಳ್ಕೊಳ್ಳಿ, calcium chloride ಕೊಡ್ತಿದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ, ಆಯ್ತಾ? So calcium is actually giving the electron to the chloride itself. In this way you can understand it. Okay. Next, Causal's postulates provide the basic for the model concepts like regarding the ion formation by the electron transfer and the formation of the ionic crystalline compounds also. Like because of this only bond formations are happening in between the elements. Clear? Like calcium is giving the electron to the chloride, the bond is been forming. The bond is been forming. So reply, good evening. Okay. Hi, good evening, Darshan. Good evening. Okay. So then next comes his views have proved to be the great value in the understanding and the systemization of the ionic compounds. At the same time, he did recognize the fact that a large number of compounds did not fit into this concepts. So large number ennu ಜಾಸ್ತಿ ಅಕಸ್ಮಾತ್ ಇದನ್ನಿದ್ರೆ atomic number ಜಾಸ್ತಿ ಇದ್ರೆ ನಿಮ್ಗೆ ಹೇಗಾಗುತ್ತಪ್ಪ? How it's possible? Right? How it's possible? It's not possible only. No. In Lewis dot structure nalli, in case ಜಾಸ್ತಿ valence electrons outermost shell nilidre, ಕುಂತ್ ಹಾಕೊಂತ್ಕೊಂಡ್ಲಿಕ್ಕೆ ಬರಲ್ಲ. So that it didn't work for the few things. Like large number if it is there, this Causal's rule or Lewis dot, it didn't work. Clear? If it is having a large number. Next comes the octet rule. So octet rule is a very important topic. So octet rule mele one NEET question 100% ಕೇಳ್ತಾರೆ, ಆಯ್ತಾ? So ಇದನ್ನ ಬರ್ಕೊಂಬಿಡಿ. Next, atoms from the chemical bonds in order to complete their octet means what? I want to become a Ambani. To finish that octet, I want in my means example, nan salary account, sorry, like any account, okay, ನಂದು ಎಲ್ಲಿ salary ಬರ್ತಿದೆಯಲ್ಲ ಆ ಅಕೌಂಟ್ ನಲ್ಲಿ ನನಗೆ ಅಕಸ್ಮಾತ್ ಅಂಬಾನಿ ತರ ಆಗೋದಿದೆ ಅಂದ್ರೆ ಒಂದು 10 ಕೋಟಿ 20 ಕೋಟಿ ಬೇಕಪ್ಪ. ಸೇಮ್ ಅದೇ ತರ ಆ ಕೋಟಿ ಬರೀಲಿಕ್ಕೆ ಒಂದು 10 ಕೋಟಿ 20 ಕೋಟಿ ನನ್ನ ಅಕೌಂಟ್ ನಲ್ಲಿ ಬರಬೇಕಲ್ಲ. ಐ ವಾಂಟ್ ಟು ಬಿ ಅ ಅಂಬಾನಿ ರೈಟ್ ನೌ. ಸೊ ಆ ಬರ್ಲಿಕ್ಕೆ ನಾ ಎಲ್ಲಾರ ಕಡೆ ನಿಸ್ಕೊಂಡ್ ಬರ್ತೇನೆ. ಲೈಕ್ ಐ ಆಮ್ ಸ್ನ್ಯಾಪಿಂಗ್ ಇಟ್, ಐ ಆಮ್ ಟೇಕಿಂಗ್ ಫ್ರಮ್ ದಿಸ್ ಪರ್ಸನ್, ಐ ಆಮ್ ಟೇಕಿಂಗ್ ಫ್ರಮ್ ದಟ್ ಪರ್ಸನ್, ಸೊ that I'll complete my octet. Then my account will be like increasing the amount there, then I'll act like Ambani. So that is what is actually happening in the electrons also. All the elements want to act like a Ambani. For that purpose they are taking the elements, electrons from the other people. Clear? So now atoms from the chemical bonds in order to complete their octet, that is 8 electrons in their valence shell. So ಎಷ್ಟು ಇರಬೇಕು? ನಾ 20 ಕೋಟಿ ಅಂತ ಹೇಳಿದಲ್ಲ, ಸೇಮ್ ಅದೇ ತರ ಈಗ 8 electrons ಇರಬೇಕು ಅವ್ರ ಅಕೌಂಟ್ ನಲ್ಲಿ. ಓಕೆ, ಸೊ ನನ್ನ ಅಕೌಂಟ್ ನಲ್ಲಿ 20 ಕೋಟಿ ಹೇಗಿರ್ಬೇಕಲ್ಲ, ಸೇಮ್ ಅದೇ ತರ ಈಗ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 8 electrons ಇರಬೇಕು ಔಟರ್ ಮೋಸ್ಟ್ ಶೆಲ್ ನಲ್ಲಿ. ಓಕೆ, ಸೊ ಔಟರ್ ಮೋಸ್ಟ್ ಶೆಲ್ ನಲ್ಲಿ ಇಫ್ ಇನ್ ಕೇಸ್ ಇಟ್ಸ್ ಹ್ಯಾವಿಂಗ್ 8 electrons, then they will complete their octet. Means what? They are actually acting like an Ambani. They are acting like an Ambani, but they are not not Ambani, because anytime that can be removed. That can be removed. Clear? Next, in their valence shell and Lewis structure is what? Pair of bonded electrons in is by means of dash. So this is the Lewis structure. Usually it is also called as a bond. So how the bonds are being forming here. Understand it properly. This is very important. Okay. Lone pairs of non-bonded electrons are represented by dots. How it is represented? In the form of a dots. Like example, outermost shell nalli ಎಷ್ಟು electrons ಇದೆಯಲ್ಲ ಅದನ್ನ ಆ ತರ ಮಾಡ್ತಾರೆ. Who is main in Ambani Kutumba, ma'am? Ambani Kutumbnalli yaar main idara? I don't know that. So lone pairs are non-bonded electrons and are represented by the help of dots. So yavya lone pairs means what? They are lonely. Okay, if I tell you simple way, okay, lonely are daralla avrella non-bonded electrons, so means they can't bond with anyone. So example tagoda, electron is actually present in the last shell of the atoms, which is going to be the valence electrons, means idedara. Okay, ಇಲ್ಲಿ ಯಾವುದು ಇದೆ ಅಲ್ಲ outermost shell ನಲ್ಲಿ ಎಷ್ಟು electrons ಇದೆ ಅಲ್ಲ ಅದಕ್ಕೆ valence electrons ಅಂತ ಕರೀತಾರೆ. What is this called as? Valence electrons. ತಿಳಿತಾ? Yes. So next comes here the example which people need to understand. ಇಲ್ಲಿ ammonia ಕೊಟ್ಟಿದ್ದಾರೆ NH3. So ಇಲ್ಲಿ ನೋಡಿ ammonia N is having at the center and the hydrogens are being surrounded to that. Okay. Outermost shell ನಲ್ಲಿ ಎಷ್ಟಿದೆ ಅದನ್ನ dot structure ನಲ್ಲಿ ಹಾಕಿದ್ದಾರೆ. Already ನಾ example ಅನ್ನು ಕಲಿಸಿದ್ದೇನೆ, right? Is it enough for the NEET? I mean in chemistry. So in chemistry, who is the Ambani? So in chemistry, many are the Ambanis. All the noble gases are actually Ambani. Okay. Helium is actually less Ambani. Living helium, all the elements are actually Ambani itself. Is it enough for the NEET? Yes, this is enough for the NEET because this is completely about the theory I am telling you. ಆಮೇಲೆ questions ಅನ್ನು ತಗೋತೇನೆ NEET questions ಅನ್ನು. So first ನೀವು theory concept ಅನ್ನು understand ಮಾಡ್ಕೊಳ್ಳಿ, NEET questions easy ಆಗಿ solve ಮಾಡ್ಕೋಬಹುದು. ಆಯ್ತಾ? So this is how the bonds has been forming. Nitrogen. So this is getting bonded with 3 hydrogens. Okay. More hydrogen jode react ಆಗ್ತಿದೆ. So these are bonds. Okay. ಈ ತರ bonds ಅನ್ನ ಬರೀತಾರೆ. Next comes what? Octet rule. In detail we are going to understand. So that is Casuals and Lewis in 1916 developed an important theory. It's visible. Yes. Theory of a chemical combination between the atoms known as electrostatic theory of a chemical bonding. That is what? The bonding like covalent, ionic, coordination. You more in bonding ಆಗ್ತದಲ್ಲ ಅದನ್ನ detail ಆಗಿ understand ಮಾಡ್ಕೊಳ್ಳೋಣ. ಅದನ್ನ ಯಾರು ತೆಗೆದಿದ್ದಾರೆ? Casual ತೆಗೆದಿದ್ದಾನೆ. ಆಯ್ತಾ? Now according to this, atoms can combine either by transfer of the valence electrons, means it might transfer the valence electrons like outermost shell nalli. In case sodium is actually having one has its outermost shell. Okay, so in the outermost shell nalli sodium nalli ಒಂದೇ ಇದೆ. ನಾನು ಸುಮ್ಮನೆ ಇಟ್ಕೊಂಡು ಏನು ಮಾಡೋದು? So I will give it to the chlorine. Now chlorine needs how many octet? It needs 1 electron to complete its octet. Okay, so sodium chlorine ಕೊಟ್ಬಿಡುತ್ತಪ್ಪ. Okay, sodium will give a chlorine ko atom. Like example I will tell you. Say ಈಗ sodium ಕಡೆ 1 electron ಇದೆ. Okay, 1 at the outermost shell. So this will actually give it to chlorine. Why? Because chlorine needs 1 electron to complete its octet. To complete its octet. ತಿಳಿತಾ? So ಇದು ಕಂಪ್ಲೀಟ್ ಮಾಡ್ತಿದ್ರೆ ಆಕ್ಟೇಟ್ ಅನ್ನ ಅದಕ್ಕೆ 1 electron ಕೊಡ್ಬೇಕಪ್ಪ. So ಇದು ಕೊಟ್ಬಿಡುತ್ತೆ. So NaCl will be happy because it is stable. It is already acting like a Ambani right now. Simple to understand. Right? Yes. Next comes what? Covalent bond. So before that, understood about the octet rule? ತಿಳಿತಾ octet rule ಅಂದ್ರೆ ಏನು? This is called as a octet rule. Okay. Electrons, in order to have an octet in their valence shells, that is 8 electrons. Outermost shell nalli 8 electrons ಬೇಕೇ ಬೇಕು. 8 electrons ಇದ್ರೆ they have reached their octet. Means they have completed their octet. Okay, that is called as a octet rule. First we are going to learn about the covalent bond. Okay, what is the meaning of a covalent bond? So here what that the Lagmier did in 1919, he refined the Lewis postulates by abandoning the idea of the stationary cubical arrangement of the octet and by introducing the term called as covalent bond. So he had told some things, Casual had told something. Okay, now ನೇನ್ ಮಾಡ್ದ, ನೀ ಏನ್ ಮಾಡ್ಕೋತಿ ಮಾಡ್ಕೋಪ, ನಂದಂತೂ ಬೇರೆನೇ ಇರೋದು. I will going to do you people something different only. Let me try it by introducing the covalent bond. Means covalent bond ಅನ್ನ introduce ಮಾಡೋಣ. ಆ ತರ ಹೇಗೆ ಬಾಂಡ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ಅದನ್ನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳೋಣ ಆಯ್ತಾ. Yes, Chinny, your heart is very burning. Okay. So the Lewis-Langmuir theory can be understood by the configuration. Like which configuration they have taken about the Cl2. Okay. Now that formation of chlorine molecule, that is Cl2, the Cl atom with electrons configuration of Ne 3s2 3p6. Okay. Now is one of the electron short of the argon configuration. So this is a short form. Idre enu full doddu one electron configuration bariyu badli now ಏನು ಮಾಡ್ಕೋಬಹುದು, we can take one of the noble gas. With that we can write the electronic configuration. That will be easy to understand. Okay, that will be easy to understand. Yes, NEET clear ಮಾಡಿಬಿದ್ರೆ ಲೈಫ್ ಸೆಟಲ್ ಅಪ್ಪ. ಆಲ್ರೆಡಿ ಡಾಕ್ಟರ್ ಆಗ್ತಿದ್ದೀರಾ, ಇನ್ನ ಏನು ಸೆಟ್ ಮಾಡ್ಕೋತಿದೀಯಪ್ಪ ನೀನು. Is one of the electron short of the argon configuration, and the formation of Cl2 molecule can be understood in terms of a sharing of the pair of the electrons between the two chlorine atoms. Each chlorine atom contributing one electron to the shared pair in the process by both. Example, concentric properly now how it's been actually been forming. Here chlorine is there. Okay, chlorine is having how many at the outermost shell? 4, 5, 6, 7. 7 is there. Okay. It's having how much? 7 are there. Now just Cl2 they have told. They have told us to take Cl2. ಇಲ್ಲಿ ಒಂದು Cl ಇದೆ, ಇದು ಒಂದು Cl. ಎರಡು ಕಡೆ 7 electrons ಇದೆ. Total ಎಷ್ಟಾಯ್ತವು? 14 ಆಯ್ತು. ಈಗ ಇಲ್ಲಿ ಒಂದು electron ಏನಿದೆ, ಇದು ಒಂದು electron ಇದೆ. Okay, one electron. Means what? Chlorine needs 2 electrons. Cl2 needs 2 electrons to complete its octet. ಆಯ್ತಾ? So ಅದಕ್ಕೆ ಏನು ಮಾಡುತ್ತೆ? ಒಂದು Cl ಇನ್ನೊಂದು Cl bond ಆಗಿಬಿಡುತ್ತೆ. How it will bond? With the covalent bonding. ತಿಳಿತಾ? ಸಿಂಪಲ್. ಓಕೆ, ಬಹಳ ಸಿಂಪಲ್ ಇದೆ. ಈಗ ನೋಡಿ Cl ಇದೆಯಪ್ಪ. ಓಕೆ, ಈ Cl ಏನು ಮಾಡುತ್ತಲ್ಲ, ಈ Cl ಗೆ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಬೇಕಿದೆ. ಸೊ ಇನ್ನೊಂದು Cl ಇದೆ, ಇದಕ್ಕೂ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಬೇಕಿದೆ. ಬಿಕಾಸ್ ವಿ ಆರ್ ಟೇಕಿಂಗ್ ದ Cl2 ಆಸ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್. ಓಕೆ, ಇದಕ್ಕೆ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಬೇಕಿದೆ, ಇದಕ್ಕೂ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಬೇಕಿದೆ. ಸೊ ಎರಡು ಎಲೆಕ್ಟ್ರಾನ್ ಕಂಬೈನ್ ಆಗ್ಬಿಡುತ್ತಪ್ಪ. ಒನ್ ಎಲೆಕ್ಟ್ರಾನ್ ವಿಲ್ ಬಿ ಶೇರ್ ಟು ಒನ್ ಮೋರ್, ರೈಟ್? ದೇ ಬೋತ್ ವಿಲ್ ಬಿಕಮ್ ಹ್ಯಾಪಿ. They both will become happy. Cl2 will bond. Then which bond is in between this? Yeah, bond ide idralli. This is having a covalent bond. It's having what? Covalent bond. Simple. Okay? It's bonds covalent bond. Hi Ravi. Good question bro. Yes, this is a very good question. Okay. So illi nodi. 1 second guys. Yes. So 7 electrons, both the electrons will combine. It will become 8 electrons. We need 8 electrons to complete its octet, right? So 8 electrons ide appa nankade. So we are happy. We are octet. We have completed the octet, right? Now, chlorine atoms again the outermost shell octet of the nearest noble gas, that is argon. Andre argon jodi nearest agide. Means ಹೇಳ್ತಾರಲ್ಲ, ಈಗ ನೀವು ಗೂಗಲ್ ಅಲ್ಲಿ ಸರ್ಚ್ ಮಾಡಿದ್ರೆ who is the richest person, who will come first, so second who will come, you people will see the net worth of them, right? So ಅಂಬಾನಿ ಎಷ್ಟು net worth ಇದೆ, ಮತ್ತೆ ಬಿಲ್ಸ್ ಗೇಟ್ ಎಷ್ಟಿದೆ net worth. ಸೊ ಅದ್ರ ಪ್ರಕಾರ ನೀವು ನೋಡ್ತೀರಾ. ಓಕೆ, ಸೊ sometimes if the turnover has come very good, so are near ಆಗುತ್ತೆ. So same ಅದೇ ತರ chlorine ದು 8 octet rule complete ಆಗಿದೆ, ಅದಕ್ಕೆ nearest to the argon. Means it might be nearer to the argon. Clear? Now next, the dots represent the electrons. Such structures are referred as a Lewis dot structure. So ಈ ತರ ಎಲ್ಲಾದರೂ representation ಮಾಡಿದ್ರೆ ಇದಕ್ಕೆ Lewis dot structure ಅಂತ ಕರೀತಾರೆ. Now Lewis dot structures can be written by other molecules also, in which the combining atoms may be identical or different, and the important conditions being that, so ಬೇರೆ ತರನು ಈ chlorine same elements ತಗೊಂಡಿದ್ದೇವೆ. Okay, we can do it with a different one. Chlorine also I can take, with hydrogen also I can take, hydrogen and chlorine also I can take, no problem. Okay, so Elon Musk. Who is Elon Musk? I helped for midterm exam. I helped for midterm. Ravi, ನೀನು ಹೆಲ್ಪ್ ಮಾಡಿದಪ್ಪ, ನಾ midterm exam ಬರ್ದಿಲ್ಲ. Next, so each bond is formed as a result of sharing of an electron pair between the atoms. Each combining atom contributes at least 1 electron to the shared pair. It will 1 electron to the shared pair. Okay, 1 electron at least ಕೊಡುತ್ತೆ. Then the combining atoms attain the outermost noble gas configuration as a result of sharing the electron, and thus in the water and carbon tetrachloride molecules formation of the covalent bond can be represented. Clear? Ill considered ಮಾಡಿ. Hydrogen ಇದೆ ಒಂದು ಎಲೆಕ್ಟ್ರಾನು, ಹೈಡ್ರೋಜನ್ ಇಲ್ಲೊಂದಿದೆ ಇನ್ನೊಂದು ಪೇರ್ ಇದೆ, ಆಕ್ಸಿಜನ್ ನಲ್ಲಿ 4 ಇದೆ. ಸೊ ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 4 ಅಂತ ಬರೆದಿದ್ದಾರೆ. ಸಿ ದ ಬೋತ್ ಗಾಟ್ ಕಂಬೈನ್ಡ್ 2 electrons, 8 electrons, 2 electrons. Clear? Now concentrate properly how it happening in the same with the CCl3, CCl4. Okay, CCl4 ನಲ್ಲಿ ಇದೇ ತರ ಆಗ್ತಿದೆ ಬಾಂಡಿಂಗ್. ಆಯ್ತಾ? ಸೇಮ್ ಇದರಲ್ಲಿ ಹೆಂಗಿದೆಯಲ್ಲ ಅದೇ ತರ. ಗುರುರಾಜ್ ನಿನ್ ಗರ್ಲ್ ಫ್ರೆಂಡ್ ಇಲ್ವಾ? ಸೊ ಗುರುರಾಜ್ ಯು ಹ್ಯಾವ್ ಅ ಗರ್ಲ್ ಫ್ರೆಂಡ್ ಆಲ್ಸೋ? ಇಲ್ಲ ಕಿಂಗ್. ಓಕೆ, ಗುರುರಾಜ್ ಗರ್ಲ್ ಫ್ರೆಂಡು ಬರ್ತಾಳ ಕ್ಲಾಸ್ಗೆ? ಅಯ್ಯೋ ನನಗೆ ಗೊತ್ತೇ ಇರಲಿಲ್ಲಪ್ಪ ಗರ್ಲ್ ಫ್ರೆಂಡ್ ಬಾಯ್ ಫ್ರೆಂಡ್ ಇಬ್ರು ಕ್ಲಾಸಿಗೆ ಬರ್ತಾರಂತ. ಸೊ ನಮಗೂ ಒಂದು ಸ್ವಲ್ಪ ಹೇಳಿ ಯಾರ್ಯಾರು ಗರ್ಲ್ ಫ್ರೆಂಡು ಯಾರ್ಯಾರು ಬಾಯ್ ಫ್ರೆಂಡ್ ಅನ್ನೋದು. ನಿಮ್ಮ ಮಮ್ಮಿ ನನ್ಗೆ ಬಂದು ಬೈತಾಳೆ ಇಲ್ಲಿ, ಆಯ್ತಲ್ಲ? ಸೊ ಕಲೀರಿ ಸ್ವಲ್ಪ, ಆಮೇಲೆ ಗರ್ಲ್ ಫ್ರೆಂಡ್ ಮಾಡ್ಕೊಳಕ್ರೆ. ಮುಂದೆ ಯಾರಾದರೂ ಡಾಕ್ಟರ್ ಆದ್ರಿ, ಇಂಜಿನಿಯರಿಂಗ್ ಆದ್ರಿ, ಎಲ್ಲ ಆದ ತಕ್ಷಣ ನಿಮ್ಮ ಹುಡುಗಿಯರನ್ನೇ ಹಿಂದೆ ಬರಬೇಕು, ಆ ಥರ ಕುಂತು ಓದಬೇಕು. ನೀಟ್ ಕ್ವಾಲಿಫೈ ಮಾಡಿ, JEE ಕ್ವಾಲಿಫೈ ಮಾಡಿದರೆ, KCET ಕ್ವಾಲಿಫೈ ಮಾಡಿದ್ರೆ ತಂತನ ಹುಡುಗಿಯರು ಹಿಂದೆ ಬರ್ತಾರೆ. ತಿಳಿತಾ? ಆಮೇಲೆ ಗರ್ಲ್ ಫ್ರೆಂಡ್ಸ್ ಎಲ್ಲ ವೇಟ್ ಮಾಡೋದು ನೆಸೆಸಿಟಿ ಇಲ್ಲ. Next, thus when two atoms share one electron pair, they are said to be joined by a single covalent bond. Single covalent bond ಹೇಗಾಗುತ್ತೆ? ಯಾವಾಗ electron pair are said to be joined, that all are going to be the single covalent bond. Ma'am, what a joke. It is not a joke, I'm serious guys. Serious ಆಗಿ ಹೇಳ್ತಿದ್ದಾನಪ್ಪ. ಗರ್ಲ್ ಫ್ರೆಂಡ್ ಬಾಯ್ ಫ್ರೆಂಡ್ ಹೆಂಗೆ ಆಗ್ತಾರೆ? ಸೊ ನೀವು ಯಾವಾಗ ಹುಡುಗರು ಕುಂತು ಓದ್ರಿ, ಚೆನ್ನಾಗಿ ಕುಂತು ಓದ್ರಿ, ಚೆನ್ನಾಗಿ ಹುಡುಗಿಯರು ತಾನೇ ಬರ್ತಾರೆ. ಸೊ ಹುಡುಗಿಯರನ್ನು ಚೆನ್ನಾಗಿ ಕೂತೋದ್ರೆ ಹುಡುಗರು ತಾಂತಾನೆ ಹಿಂದೆ ಬರ್ತಾರೆ. ಸೊ ಈಗ ಎಲ್ಲರಿಗೂ ಎಜುಕೇಶನ್ ಬೇಕಪ್ಪ. ಸುಮ್ಮನೆ ಕುಂತು ಹುಡುಗಿಯರು ಹಿಂದೆ ಬರ್ರಿ, ಹುಡುಗರು ಹಿಂದೆ ಬರ್ಲಿ ಅಂದ್ರೆ ಬರಲ್ಲ ಯಾರು. ತಿಳಿತಿಲ್ಲ? ಎಲ್ಲರಿಗೂ ಅಂಬಾನಿ ಆಗೋದಿದೆ ಏನಿಲ್ಲ. ಎವ್ರಿ ಒನ್ ವಾಂಟ್ಸ್ ಟು ಬಿ ಅಂಬಾನಿ ಆರ್ ನೋ? ಅಂಬಾನಿ ಆಗ್ಬೇಕಂದ್ರೆ ಏನಿರ್ಬೇಕು? ಅಂಬಾನಿ ಕಡೆ ಏನಿದೆ? ಅಂಬಾನಿ ಆಗ್ಬೇಕಂದ್ರೆ, ಅಂಬಾನಿ ಹಂಗೆ ಆಗ್ಬೇಕಂದ್ರೆ ಕುಂತು ಓದ್ಬೇಕು. ಹಂಗೆ ಫಸ್ಟ್ PUC ಆದ್ಮೇಲೆ ಅಂಬಾನಿ ಆಗಲ್ಲ ಯಾರು. ಓಕೆ, so we have multiple bonds between the atoms, and the formation of the multiple bonds envisages the sharing of the more than one electron pair between the two atoms. So if two atoms share two pairs of electrons, okay, two atoms are sharing two pairs of electrons, okay, two atoms are there, two atoms, so two pairs of sharing means two pairs of electrons are getting shared in between two atoms, okay, that the covalent bond between them is called as what? Double bond. It's called as what? ಡಬಲ್ ಬಾಂಡ್. ತಿಳಿತಾ? ಡಬಲ್ ಬಾಂಡ್ ಯಾವಾಗ ಆಗುತ್ತೆ? ಯಾವಾಗ ಎರಡು ಆಟಮು ಟೂ ಪೇರ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನ ಶೇರ್ ಮಾಡ್ತಿದೆ. ಟೂ ಪೇರ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಶೇರಿಂಗ್, ದಟ್ ಟೈಮ್ ಓನ್ಲಿ ಡಬಲ್ ಬಾಂಡ್ ಇಸ್ ಗೋನಾ ಫಾರ್ಮ್. ಯಸ್, पैसा है तो सब कुछ हो जाएगा. मनी इज देयर ಅಂದ್ರೆ ಆಗೋದು. ತಿಳಿತಾ? ಸೊ ಎವ್ರಿವನ್ ವಾಂಟ್ಸ್ ಟು ಬಿಕಮ್ ಅಂಬಾನಿ ಓನ್ಲಿ ಹಿಯರ್. So next example, in the carbon dioxide molecule, we have two double bonds between the carbon and the oxygen. So il double bond example ಕೊಡ್ತಿದ್ದಾರೆ. ಈಗ ಏನು ಡೆಫಿನೇಷನ್ ಕಲಿಸ್ದಲ್ಲ ಅದರದ ಎಕ್ಸಾಂಪಲ್ ಇದು. So carbon ಇದೆ, right? Two oxygens are present here. Clear? So here we know already it is having a 8 electrons, ಆಯ್ತಾ? So 8 electrons carbon ನಲ್ಲಿ, because C2 one ನಾಲ್ಕು ಇನ್ನೊಂದು ನಾಲ್ಕು, ಆಯ್ತಾ? So same oxygens ಎಲ್ಲಿದೆ? 8 electrons. Done. So because this is forming the this is how the formation is going to happen. This is how the covalent bonding is happening. Very simple to understand. Clear? So same way ಇಲ್ಲಿ C2H4 molecule ದುನು ಆಗಿದೆ. ಇಲ್ಲಿ C2H4 molecule ಚೆಕ್ ಮಾಡ್ಕೋಬಹುದು. So carbon carbon in between it is having how? ಇಲ್ಲಿ 4 ಇದೆ, ಇಲ್ಲಿ 4 ಇದೆ. ಈ 4 ಡಬಲ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. You can just observe 4 electrons are present here. So ಇಲ್ಲಿ 4 ಸಲುವಾಗಿ ಡಬಲ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗ್ತಿದೆ ಇಲ್ಲಿ, ಆಯ್ತಾ? So now next, when combining atoms share the 3 electron pairs as in the case of a 2 nitrogen. So ಇಲ್ಲಿ nitrogen ನಲ್ಲಿ 3 pairs of electrons are getting transferred. Okay, ಈಗಿನ ತನಕ ನಾವು 2 pairs ಅನ್ನು ತೆಗೆದ್ವಿ. ಈಗ 3 pair of electrons ಇದೆ. Okay, ಈ 3 pair of electrons ನಲ್ಲಿ 2 nitrogen atoms in the N2 molecule and the 2 carbon atoms in the ethyne molecule, a triple bond is being formed. So ಇಲ್ಲಿ ಏನು ಫಾರ್ಮ್ ಆಗುತ್ತೆ? ಟ್ರಿಬಲ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಯಾವ ತರ? because there is a share of a 3 pair of electrons. 2 atoms between 3 pair of electron share ಆಗ್ತಿದೆ. If in case 3 pairs of electrons are getting shared, that is called as what? That is called as triple bond. Simple. Understood? Understood everyone? ತಿಳಿದಿದೆನಾ? ತಿಳಿದಿದೆನಾ? Next comes C2H2 molecule. This one simple example ide. Understand this also properly everyone. Simple example, ella examples togolodu beda aita. So next comes exceptional to the octet rule. So ಏನಪ್ಪ ಇದೆ exceptions in octet rule ನಲ್ಲಿ ಅದನ್ನ understand ಮಾಡ್ಕೊಳ್ಳೋಣ. So spaces with odd number of electrons, that is NO, NO2, are all like a exceptional comes. Okay, exceptional anta ಬರುತ್ತೆ. So incomplete octet for the central atom, like example Li means lithium chloride, beryllium hydrogen and boron chloride, like BCl3, and expanded octet for the central atom like F5 and SF6 and H2SO4. These are the simple examples for the exceptional ಅಂದ್ರೆ ಏನು octet rule ಆಗಲ್ಲ. So ಈ elements ನಲ್ಲಿ octet rule ಆಗಲ್ಲ. Clear? Chemistry chapter illa life chapter. Yes, because chemical bonding is a life chapter itself. Chemical bonding nalli now life chapter bal kaliteve because it's related to the real life itself. Okay, it's related to the real life itself. So understand it properly so that your real life and real life both will get sorted out. Okay, formal charge. Gururaj, your girlfriend didn't come. Okay, formal charge. Formal charge is the difference between the number of valence electrons in an isolated atoms and number of electrons assigned to that atoms in a Lewis structure. In that atoms of a Lewis structure. Now, formal charge. This is very important to understand. This is very important to that. So, this concept is very important to that. Formal charge is actually equal to what? Total number of valence electrons. Total number of valence electrons in the free atom. Free atom nalli ಎಷ್ಟು total number of valence electrons ಇದೆ. Valence electrons ಇದೆ outermost shell ನಲ್ಲಿ ಎಷ್ಟಪ್ಪ free electrons ಇದೆ minus total number of lone pairs. Total number of lone pairs of electrons. Lone pair ಅಂದ್ರೆ ಏನು ಎಷ್ಟು pair ಆಗ್ತಿದೆ lone pairs which is getting how much it has been paired. Okay, 2 pairs or 3 pairs or depends on that. Okay, ಎಷ್ಟು bonding ಆಗ್ತಿದೆ minus half the total number of shared electrons, that is bonding electrons. ಎಷ್ಟು bond ಆಗ್ತಿದೆ means how much I am giving the electron to the other person to bond. ನಾನು ಸೋಡಿಯಂ ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ, ನೀವು ಕ್ಲೋರೈಡ್ ಇದೀರಾ, ನಾ ಎಷ್ಟಪ್ಪ ಎಲೆಕ್ಟ್ರಾನ್ ನಿಮಗೆ ಕೊಡ್ತಿದ್ದೇನೆ ಬಾಂಡ್ ಆಗ್ಲಿಕ್ಕೆ, ಅದಕ್ಕೆ ಏನು ಕರೀತಾರೆ? shared electrons. ಅದಕ್ಕೆ ಏನು ಕರೀತಾರೆ? shared electrons. So ma'am joke ಜೋಕ್ ಮಾಡಿದ್ದಿ ಗುರುರಾಜ, ನಂಗೆ ಸೀರಿಯಸ್ ಆಗಿ ಅನ್ಸ್ಬಿಡ್ತಲ್ಲಪ್ಪ, ನಾನು ತಿಳ್ಕೊಂಡೆ ನಿಮ್ಮ ಮಮ್ಮಿಗೆ ಹೋಗಿ ಹೇಳ್ಬಿಡ್ತೇನಂತ. So this is called as a formal charge. Formal charge is actually equal to the total number of valence electrons in the free atom minus total number of lone pairs of the electrons minus half the total number of electrons which has got shared. Clear? Now let us understand it in detail. Let us consider the ozone molecule, that is O3, and this Lewis structure is going to be O3 where here one pair of electron is present. Understood? Here one more is there, here one more is there. Now completely understand. Nan ಏನು ಹೇಳಿದ್ದೆ, in case 2 pairs ಇದ್ರೆ double bond ಇರುತ್ತೆ. Right? Here 3 pairs are there, then it is going to be the single bond. Clear? Understanding? Yes. Understanding this much, very easy to understand. Okay, the atoms have been numbered as 1, 2 and 3, 1, 2 and 3, and the formal charge on, and the central atom O atom is marked as 1. This is central atom. Okay, this is going to act like a central atom. This central atom ಇದೆ ಆಯ್ತಾ. So this central atom which is present there, the 2 more electrons has been connected to it. Oxygen shared electron connect ಆಗಿದೆ. ಈಗ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ central atom ಫೈಂಡ್ ಮಾಡೋಣ ಫಸ್ಟ್ according to the formula which I have told you previously. ಫಾಸ್ಟ್ ಆಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ನಾನು ಚಾಟ್ ಬಾಕ್ಸ್ ನಲ್ಲಿ ಹೇಳ್ಬೇಕು ಈಗ ಸದ್ಯ. ಓಕೆ, ನಾ 20 seconds ಕೊಡ್ತೇನೆ, ನಾ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡೋಕ್ಕಿಂತ ಮೊದಲು ಚಾಟ್ ಬಾಕ್ಸ್ ನಲ್ಲಿ ಆನ್ಸರ್ಸ್ ಇರಬೇಕು. So here the central atom marked as an 1. So first ಏನು 6. 6 ಅಂದ್ರೆ ಏನು? ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ದ ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇನ್ ದ ಫ್ರೀ ಆಟಮ್. ಎಷ್ಟಪ್ಪ ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಲ್ಲಿ ಫ್ರೀ ಆಟಮ್ಸ್ ಇದೆ? 6 ಇದೆ ಆಯ್ತಾ. 6 ಹಾಕಿದ್ವಿ. ಮೈನಸ್ ಇಸ್ ವಾಟ್? ಮೈನಸ್ ದ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಷ್ಟಿದೆ? 2 ಇದೆ. that is 2, which we have written it already, minus half the 6. 6 ಅಂದ್ರೆ ನಿಮಗೆ already ಗೊತ್ತಿದೆ. 6 is actually the electrons which has been shared. Means ನಾ ಇಷ್ಟು 6 electrons ಅನ್ನ ಕೊಡ್ತಿದ್ದೇನೆ. Done. So that will be what? 2. Then 6 it will be plus 1. How much will be the answer? That will be plus 1. Clear? Ma'am, first PUC or second PUC? This is first PUC, Supriya. First PUC though. Now the end oxygen atom marked as a 2. So end oxygen atom is marked as a 2. That how much is going to be? Same ಅದೇ ತರ ಮಾಡಬೇಕು, ಸ್ವಲ್ಪ changes ಆಗುತ್ತೆ. That is going to be here 2 ಇದೆ, ಇಲ್ಲಿ 4 ಇದೆ lone pair. Okay. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ 6 ಇದೆ, which is a 6 shared electron 6 ಇದೆ. ಇಲ್ಲಿ shared electrons are 4. So 4 atoms ನ share ಮಾಡ್ತಿದೆ. It's sharing. It's given 2 here. This is getting shared to 4. It's becoming double again. Okay. It's becoming double. So that will be 0. Then next the O, that is going to be the third one. Same ಅದೇ ತರ ಇದೆ, but ಇಲ್ಲಿ changes ಆಗುತ್ತೆ because ಇದು ಕೊಡ್ತಿದೆ ಅಲ್ಲ already. Oxygen ಕೊಡ್ಕೊಂತು third oxygen ಅಲ್ಲಿ ಏನಾಗುತ್ತಪ್ಪ 6 ಆಗಿಬಿಡುತ್ತೆ ಆಯ್ತಾ. So 6 the half divided by 2 is equal to minus 1. Means what? It is giving 1 pair of electron to this. Clear? ಈ ಆಕ್ಸಿಜನ್ ಮೂರನೇ ಆಕ್ಸಿಜನ್ 1 pair of electron 1ನೇ ಆಕ್ಸಿಜನ್ ಕೊಡ್ತಿದೆ. For that purpose it's having only single bond. Clear? It's giving 1 or 2, so it's going to be double bond. Ma'am, chemical kinetics live ಮಾಡಿ please, full of doubts. Yes, I'll do it. Chemical kinetics ಮಾಡ್ತಿದ್ದೇನೆ, ಇದೆ ಮುಂದಿನ ವಾರದಲ್ಲಿ ಅದು ಬರ್ತಿದೆ ಆಯ್ತಾ. So this is how you people need to calculate according to the formal charge formula. Okay, done. Now hence we represent O3 along with the formal charges as follows. This is how you people are going to form it. Now we must understand that formal charges do not indicate the real charge separation within the molecule. So it indicating the charges on the atoms in the Lewis structure only helps in keeping the track of the valence electrons in the molecule. Like formal charges help in the selection of the lowest energy structure from the number of possible Lewis structures for the given species. For that purpose, generally the lowest energy structure is the one with the smallest formal charge. Clear? This is very important to understand. ಇದನ್ನಂತೂ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳಿ ಈ ಬಾಕ್ಸ್ ಅನ್ನ ಆಯ್ತಾ. ಲೈಕ್ ಜನರಲಿ ಇಸ್ ವಾಟ್ ಲೋವೆಸ್ಟ್ ಎನರ್ಜಿ ಸ್ಟ್ರಕ್ಚರ್ ಯಾವ್ದು ಇರುತ್ತಲ್ಲ ದಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ದ ಒನ್ ವಿತ್ ದ ಸ್ಮಾಲೆಸ್ಟ್ ಫಾರ್ಮಲ್ ಚಾರ್ಜ್. ಯಾವ್ದು ಸ್ಮಾಲೆಸ್ಟ್ ಫಾರ್ಮಲ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ, ಯಾವ್ದು ಹ್ಯಾವಿಂಗ್ ವಿಚ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ಲೋವೆಸ್ಟ್ ಎನರ್ಜಿ. ಅಂಡ್ ದ ಫಾರ್ಮಲ್ ಚಾರ್ಜಸ್ ಇಸ್ ದ ಫ್ಯಾಕ್ಟರ್ ಬೇಸ್ಡ್ ಆನ್ ದ ಪ್ಯೂರ್ ಕೋವಲೆಂಟ್ ವ್ಯೂ ಆಫ್ ದ ಬಾಂಡಿಂಗ್ ಇನ್ ವಿಚ್ electron pairs are shared equally by the neighboring atoms. Means what? Equally share ಮಾಡುತ್ತೆ. It's not like ನಾನು ಶೇರ್ ಮಾಡಲ್ಲ ಅಂತ ಎವ್ರಿ ಟೈಮ್ ಹೇಳಲ್ಲ. ಸ್ವಲ್ಪ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಿರುತ್ತಂದ್ರೆ, ಸ್ವಲ್ಪ ಎಲಿಮೆಂಟ್ಸ್ ಏನಿರುತ್ತಂದ್ರೆ ಈಕ್ವಲಿ ಶೇರ್ ಮಾಡುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನ ಆರಾಮಾಗಿ ಶೇರ್ ಮಾಡುತ್ತೆ ಆಯ್ತಾ. Next comes resonance. This is also very important concept. So resonance ಮೇಲೆ questions ಕೇಳ್ತಾರೆ. NEET ನಲ್ಲಿ resonance ಮೇಲೆ ಒಂದು question already ಬಹಳ ಸಲ ರಿಪೀಟ್ ಆಗಿದೆ. ಓಕೆ, resonance ಮೇಲೆ ಬಹಳ ಸಲ ರಿಪೀಟ್ ಆಗಿದೆ. Let's start. For molecules and the ions showing the resonance, it is not possible to draw a single Lewis structure. Okay, it's not possible to draw a single Lewis structure. Means what? Lewis structure nalli ಒಂದರಲ್ಲಿನೇ ಎಲ್ಲ ಮೆನ್ಷನ್ ಮಾಡ್ತಿದ್ವಿ. ಬಟ್ ರೆಸೊನೆನ್ಸ್ ನಲ್ಲಿ ಒಂದರಲ್ಲಿನೇ ಮೆನ್ಷನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ. ಇಫ್ ಇನ್ ಕೇಸ್ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಇದೆ ಅಂದ್ರೆ 3-4 ಸ್ಟೆಪ್ಸ್ ಆಗುತ್ತೆ. ಓಕೆ, 2-3 ಸ್ಟೆಪ್ಸ್ ಆಗುತ್ತೆ. Clear? Now, all the properties of such species can only be explained by the 2 or more Lewis structures. Example, resonance of O3. So, ozone resonance find ಮಾಡ್ಕೊಳ್ಳೋಣ. Okay, ಇಲ್ಲಿ ನೋಡ್ಕೋಬಹುದು ಆಕ್ಸಿಜನ್ ಇದೆ. Okay, ಇಲ್ಲಿ ಆಕ್ಸಿಜನ್ ಇದೆ, O3 ಇದೆ. Okay, oxygen is there which is going to actually having a O. So, ಇಲ್ಲಿ O. Clear? So, ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಇಲ್ಲಿ 2 pair of electrons ಇದೆ. Here it's having 2 pairs. ಸೊ ಇಲ್ಲಿಂದ ಎಷ್ಟು ಕೊಡುತ್ತೆ, ಇಲ್ಲಿ 3 ಪೇರ್ ಆಗುತ್ತೆ. ಡನ್. ಇಟ್ ವಿಲ್ ಗಿವ್ 3 pairs. ಸೊ ಈ ತರ ಒಂದು ಸ್ಟ್ರಕ್ಚರ್ ಇದೆಯಪ್ಪ. ಓಕೆ ಆಯ್ತಾ. ಸೊ ನಾವು ಹೌ ದ ರೆಸೊನೆನ್ಸ್ ಹಸ್ ಬೀನ್ ಫಾರ್ಮ್ಡ್. ನಾವು ದಿಸ್ ಇಸ್ ಆಕ್ಚುಲಿ ಗಿವಿಂಗ್ ಟು ದಿಸ್ ಇಸ್ ಆಕ್ಚುಲಿ ಗಿವಿಂಗ್ ಟು ದಿಸ್. ಹೌ ಯು ಗೋಯಿಂಗ್ ಟು ರೈಟ್ ಇಟ್ ನಾವು ಅಗೇನ್? ಈ ಸೇಮ್ ಅದೇ ತರ ಬರೀಬೇಕು. ಓಕೆ, ಇದು ಕೊಟ್ಟಿದ್ದು ರೈಟ್. ಇಟ್ ವಿಲ್ ಬಿಕಮ್ ಸಿಂಗಲ್, ಇಟ್ ವಿಲ್ ಬಿಕಮ್ ಡಬಲ್ ಬಿಕಾಸ್ ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಹೋಗಿದೆ. ಫ್ರಮ್ ಹಿಯರ್ ಇಟ್ ಇಸ್ ಗಿವೆನ್ ಗೋಯಿಂಗ್ ದೇ ರೈಟ್. ತಿಳಿತಾ? ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ಏನಾಗುತ್ತೆ ಈಗ? ಸೊ ಇಲ್ಲಿಂದ ಮತ್ತೆ ಇಲ್ಲಿ ಹೋಗುತ್ತೆ ಡನ್. ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಮತ್ತೆ ಹೋಗುತ್ತೆ. That is we will draw it in the dot structure. Okay. So this dot structure which I have drawn it now here, ಇದೇನು ಡಾಟ್ ಸ್ಟ್ರಕ್ಚರ್ ತೆಗಿತಿದ್ದೇನಲ್ಲ ಇಷ್ಟು, this is called as a dot structure. Clear? Understood? This is how the resonance is going to work in 2 to 3 steps. It will work in 2 to 3 steps. Next comes limitations of the octet rule and the incomplete octet of the central atom and the odd electron molecule and the expanded octet, that we are going to learn it now. First comes what? Limitations of the octet rule. ಏನಪ್ಪ ಇದೆ limitations? ನಿಮಗೆ ಗೊತ್ತಿದೆ chemistry ನಲ್ಲಿ limitations ಇಲ್ಲದ ಚಾಪ್ಟರ್ ಮುಗಿಯಲ್ಲಪ್ಪ. Okay, so this is also a chapter where we have a lots of limitations and that will be actually asked in the theory also a lot. Okay, theory ನಲ್ಲಿ ಬಹಳ ಜಾಸ್ತಿ ಕೇಳ್ತಾರೆ, ಮತ್ತೆ ಇದ್ರ ಮೇಲೆ ಅಪ್ಲಿಕೇಶನ್ ಬೇಸ್ಡ್ ನೀಟ್ ನಲ್ಲಿ ಕೇಳ್ತಾರೆ, ಮೀನ್ಸ್ ಟ್ವಿಸ್ಟ್ ಮಾಡಿ ಸ್ವಲ್ಪ ಕ್ವಶನ್ಸ್ ಅನ್ನ ಕೇಳಬಹುದು. ಆಯ್ತಾ? ಸೊ ದ ಆಕ್ಟೇಟ್ ರೂಲ್, though the useful is not universal, it is quite useful for understanding the structures of the most of the organic compounds and it applies mainly to the second period elements of the periodic table. Means second period elements ನಲ್ಲಿ ಜಾಸ್ತಿ ಅಪ್ಲಿಕೇಶನ್ ಆಗುತ್ತೆ ಆಕ್ಟೇಟ್ ರೂಲ್. So there are 3 types of exceptionals of the octet rule, which are those. First one is going to be the incomplete octet of the central atom. Okay, incomplete octet of the central atom. Central atom do incomplete ಆಗಿರುತ್ತೆ. Means what? It's giving, central atom is actually giving electrons to everyone, so it will be always be incomplete. That is one exceptional. Second is what? Odd electron molecule. So odd electron molecule andre matte last one is the expanded octet. Let us learn it in the detailed way. So in some compounds, the number of the electrons surrounding the central metal, like example lithium, you think it's a 1 pair. Okay, 1 pair tagidare. Now that is less than the 8. So this is especially the case with the elements having less than 4 valence electrons. Example lithium chloride. Lithium chloride nalli ಎಷ್ಟಿದೆ ಅಪ್ಪ? ಬರೀ 1 pair ಇದೆ. Means lithium ನಲ್ಲಿ ಒಂದು, chloride ನಲ್ಲಿ ಒಂದು, right? So lithium ನಲ್ಲಿ ಒಂದು, chloride ನಲ್ಲಿ ಒಂದು. It's very less than the 8. Octet complete ಮಾಡಲಿಕ್ಕೆ 8 ಬೇಕು. 8 electrons ನಲ್ಲಿ ಬರೀ 2 ಅಷ್ಟೇ ಇದೆ ಇವ್ರ ಕಡೆ. It means what? It still needs 6 electrons ಬೇರೆ ಕಡೆಯಿಂದ ತಗೋಬೇಕು ಅವರು. ಲಿಥಿಯಂ ಕ್ಲೋರೈಡ್ ಬೇರೆ ಜೋಡೆ ಹೋಗಿ ಫುಲ್ ರಿಯಾಕ್ಟ್ ಆಗಬೇಕು. ಮೀನ್ಸ್ ವಾಟ್? ದೇ ಆರ್ ವೆರಿ ಪುವರ್. ಲಿಥಿಯಂ ಕ್ಲೋರೈಡ್ ಬಹಳ ಪುವರ್ ಇದೆ. ಈ ಪುವರ್ ಇಂದ ಮಿಡಲ್ ಕ್ಲಾಸ್ ನಲ್ಲಿ ಬರ್ಬೇಕಂದ್ರೆ ದೇ ನೀಡ್ ಟು ಸ್ಟ್ರಗಲ್ ಅ ಲಾಟ್, ಬಹಳ ಸ್ಟ್ರಗಲ್ ಮಾಡಬೇಕು. ನೆಕ್ಸ್ಟ್ BeH2, same thing here also, that is also having same 4 electrons. ಅದ್ರ ಸಲಾಗಿ ಏನು ಪ್ರಾಬ್ಲಮ್ ಆಗುತ್ತಂದ್ರೆ ಪುವರ್ ಇರ್ತಾರಪ್ಪ ಅವರು, ಫುಲ್ ಸ್ಟ್ರಾಂಗ್ ಆಗಬೇಕಲ್ಲ, ದೇ ವಾಂಟ್ ಟು ಬಿಕಮ್ ಮಿಡಲ್ ಕ್ಲಾಸ್ ಆಗಲಿಕ್ಕೆ ಫುಲ್ ಹಾರ್ಡ್ ವರ್ಕ್ ಮಾಡಬೇಕು, ಅದೇ ಇದನ್ನ ಮಾಡಬೇಕು. ಆಯ್ತಾ? ಸೊ ದಿಸ್ ಇಸ್ ಒನ್ ಎಕ್ಸೆಪ್ಷನಲ್ ವಿಚ್ ಐ ಕ್ಯಾನ್ ಟೆಲ್ ಯು ಪೀಪಲ್. ಇಫ್ ಇನ್ ಕೇಸ್ ಇಟ್ಸ್ ಲೈಕ್ 3, 4 ಅಷ್ಟೆಲ್ಲ ಇದ್ರೆ half of the thing, no. ಈಗ ನೋಡಿ BeH2 ನಲ್ಲಿ ಆಲ್ಮೋಸ್ಟ್ ಹಾಫ್ ಇದೆ, 4 electrons ಇದೆ. ಇನ್ನ 4 electrons ಬೇಕಲ್ಲಪ್ಪ, ಹೋಗಿ ಎಲ್ಲರ ಜೊತೆ ಜಗಳಾಡಿ ಇಲ್ಲಾಂದ್ರೆ ಏನಾದ್ರು ಕೆಲಸ ಮಾಡಿ ತಗೊಂಡ್ ಬರ್ಬೇಕಲ್ಲ. That is what one exceptional is there in the octet completion. Next comes what? Odd electron molecule. Like in molecule with an odd number of the electrons, like example nitric oxide, that is NO, and the nitrogen dioxide, that is NO2, the octet rule is not satisfied for all the atoms. So ಈ octet ರೂಲ್ ಎಲ್ಲದಕ್ಕೂ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗ್ಲಿಕ್ಕೆ ಪ್ರಾಬ್ಲಮ್ ಆಗುತ್ತೆ. ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್ NO2, N ಇದೆ, ಇಲ್ಲಿ ಆಕ್ಸಿಜನ್ ಜೊತೆ 2 electrons ಇದೆ, ತಗೊಂತಪ್ಪ. ಇಲ್ಲಿ ಎಷ್ಟಿದೆ ಅಪ್ಪ? ಇಟ್ಸ್ ಹ್ಯಾವಿಂಗ್ 6. ಸೊ ಇನ್ನೊಂದು ಆಕ್ಸಿಜನ್ ಬೇಕಲ್ಲ ಇದಕ್ಕೆ. ಸೊ ದಟ್ ಇಸ್ ವಾಟ್ ದ ಪ್ರಾಬ್ಲಮ್. ಮೀನ್ಸ್ ಫ್ಯೂ ಕಂಪೌಂಡ್ಸ್ ವಿಚ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ಆಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಮಾಲಿಕ್ಯೂಲ್ ದಟ್ ವಿಲ್ ನಾಟ್ ವರ್ಕ್ ಪ್ರಾಪರ್ಲಿ ಟು ಫಿನಿಶ್ ಆರ್ ಟು ರಿಚ್ ದ ಆಕ್ಟೇಟ್ ನಂಬರ್. ಓಕೆ, ಆಕ್ಟೇಟ್ ನಂಬರ್ಗೆ ರಿಚ್ ಆಗ್ಲಿಕ್ಕೆ ಸ್ವಲ್ಪ ಪ್ರಾಬ್ಲಮ್ ಆಗಬಹುದು. ಆಯ್ತಾ? ಕ್ಲಿಯರ್? ಡನ್. ಫಾಸ್ಟ್ ಚಾಟ್ ಬಾಕ್ಸ್ ನಲ್ಲಿ ಡನ್ ಅಂತ ಹಾಕ್ಬೇಕಲ್ಲ. Next, the expanded octet. Now, elements in and beyond the third period of the periodic table have, apart from 3s and 3p orbitals, 3d orbitals also have available for the bonding. So, in a number of the compounds of these elements, there are more than 8 valence electrons. It's having more than 8 valence electrons. Some of the cases are there. Only 8 electrons ಗಿಂತ ಜಾಸ್ತಿನೇ ಇದೆ. ಆಕ್ಟೇಟ್ ರೂಲ್ ಏನು ಹೇಳ್ತಿದೆ? 8 electrons ಅಂತ ಹೇಳ್ತಿದೆ. ಬಟ್ ಒಂದೊಂದು ಕೇಸ್ ನಲ್ಲಿ 8 electrons ಗಿಂತ ಜಾಸ್ತಿನೇ ಇದೆ. ಆಯ್ತಾ? ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ? ಇನ್ ದ ನಂಬರ್ ಆಫ್ ದ ಕಂಪೌಂಡ್ಸ್ ಆಫ್ ದೀಸ್ ಎಲಿಮೆಂಟ್ಸ್ ದೇರ್ ಆರ್ ಮೋರ್ ದೆನ್ 8 electrons. ಇಫ್ ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಅ more than the 8 valence electrons around the central metal atom, this is termed as an expanded octet, and obviously the octet rule does not apply in such cases. Like example PF5, like example SF6, H2SO4. You examples nodkobodu. We have drawn the Lewis dot structure also for them. So ee Lewis dot structures nalli ನೀವು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬಹುದು ಕ್ಲಿಯರ್ ಆಗಿ. ಇಲ್ಲಿ ಏನಿದೆ 10 electrons around the p atom, here it is having 12 electrons around the s atom, here it is having 12 electrons around the s atom. This is the biggest problem which is having in the expanded octet. ಅಂದ್ರೆ 8 electrons ಗಿಂತ ಜಾಸ್ತಿ ಇದ್ರೆ ಸ್ವಲ್ಪ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆಗಬಹುದು. ಈ ಸಲ ಸೀಟ್ ನಮ್ದೆ, ಈ ಸಲ ಕಪ್ ನಮ್ದೆ ಮುಗಿತೀಗ. ಈ ಸಲ ಸೀಟ್ ನಿಮ್ದೇನಾ? ಎಸ್ ಗುರುರಾಜ್, ಈ ಸಲ ಸೀಟ್ ನಿಂದೆ. ಕಂಡ ಕುಂತ ಓದು, ಸೀಟ್ ನಿಂದೆ ಆಗ್ಬಿಡುತ್ತೆ. Next comes internally, sulfur also forms the many compounds in which the octet rule is obeyed. In sulfur dichloride, the S atom has the octet of electrons around it. The same example. Then other drawbacks of the octet theory is, it is clear that octet rule is being based upon the chemical interness of the noble gases. Means it has been interconnected with the noble gases. Okay, now however some noble gases, for example xenon and krypton, like example xenon ಮತ್ತೆ krypton avu Ambani family idalla, so also combine with the oxygen and fluorine to form a number of compounds like Se. Means sometimes this both, like example ಹೇಳ್ತೇನೆ. So like example ರಾಧಾನ ಈಗ ಹೆಸರು ರಾಧಿಕಾ ಅಂಬಾನಿ ಏನಿದಾಳಲ್ಲ, ಅವಳು ಒಂದೊಂದ್ಸಲ ಹೋಗಿ ಸ್ವಲ್ಪ ಡೊನೇಟ್ ಮಾಡ್ತಾಳೆ. ಒಂದ್ ಸ್ವಲ್ಪ ಇದನ್ನ ತಗೋ, ಸೀರೆ ತಗೋ, ಊಟ ತಗೋ. ಸೊ ದಿಸ್ ಆಲ್ ಥಿಂಗ್ಸ್ ವಿಲ್ ಬಿ ಡನ್ ಬೈ ಫ್ಯೂ ಆಫ್ ದ ಪೀಪಲ್, ರೈಟ್? ಸೊ ಅದೇ ತರ ಜಿನಾನ್ ಮತ್ತೆ ಕ್ರಿಪ್ಟಾನ್ ಏನಿದೆ ಅಲ್ಲ, ಅದೇ ತರ ಸ್ವಲ್ಪ ಡೊನೇಟ್ ಮಾಡ್ಕೊಂತ ಹೋಗುತ್ತೆ. ಇರ್ಲಿ ತಗೋ, ಒಂದ್ ಸ್ವಲ್ಪ ತಗೋ, ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ, ತಗೋ ಅಪ್ಪ, ಖುಷಿಯಾಗಿ ನೀನು, ನಾನು ಒಂದ್ ಸ್ವಲ್ಪ ಡೊನೇಟ್ ಮಾಡ್ತಿದ್ದೇನೆ ಅಂತ ಮಾಡ್ತಿದ್ದಾರೆ. ಆಯ್ತಾ? ನಾವು ದಿಸ್ SeF2, KrF2, SeOF2, these are the simple examples which is getting reacted. Means what? Ambanis are going and reacting with some of the people. Aita? Next, it does not explain the relative stability of the molecules, being totally silent about the energy of the molecules. Clear? So these are the simple other drawbacks of the octet theory. Ma'am, this class is okay for JW. Yeah, this is okay for JE also, no problem. ಮ್ಯಾಮ್ ಇನ್ಸ್ಟಾಗ್ರಾಮ್ ಇನ್ನ ಡಿಸ್ಟ್ರಾಕ್ಷನ್ ಬಹಳ ಆಗ್ತಿದೆ ಮ್ಯಾಮ್, ಟಿಪ್ಸ್ ಕೊಡಿ, ಮನೆಯಲ್ಲಿ ಬೈತಿದ್ದಾರೆ, ಹೇಳು ಪ್ಲೀಸ್. ವಿಕಾಸ್, ಇನ್ಸ್ಟಾಗ್ರಾಮ್ ನೋಡ್ಕೊತ ಕುಂತ್ರೆ ಯಾರು ಹುಡುಗಿಯರು ನೀನು ಹಿಂದೆ ಬರಲ್ಲ, ಆಯ್ತಾ? ಸೊ ಅದನ್ನ ತಲೆಯಲ್ಲಿ ಇಟ್ಕೊಂಡ್ಬಿಡು. ಬಿಕಾಸ್ ನಿನಗೆ ಯಾರಾದರೂ ಫ್ಯೂಚರ್ನಲ್ಲಿ ನಿನಗೂ ಅಂಬಾನಿ ಆಗೋದಿದೆ, ನಿನಗೂ ಒಂದು ಸ್ವಲ್ಪ ಹುಡುಗಿಯರು ಹಿಂದೆ ಬರಲಪ್ಪ ಅಂತ ತಲೆಯಲ್ಲಿದ್ದರೆ, ಪ್ಲೀಸ್ ಡೋಂಟ್ ಸಿ ದ ಇನ್ಸ್ಟಾಗ್ರಾಮ್. ಸಿಂಪಲ್ ವೇ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಇದನ್ನ ನೀನು ಯಾವಾಗ ಓದತಿರ್ತೀಯಲ್ಲ ಅವಾಗ ನೀ ತಲೆಯಲ್ಲಿ ಹಾಕೊಂಡ್ಬಿಡೋದನ್ನ, ಮ್ಯಾಮ್ ಏನು ಹೇಳಿದಾರೆ ಅನ್ನೋದು ಇದನ್ನ ತಲೆಯಲ್ಲಿ ಹಾಕೋ, ನಾನು ನೋಡ್ತೇನೆ ನಿನಗೆ ಹೆಂಗೆ ಓದಂಗಿಲ್ಲ ನೋಡಿ. ಸೊ ಯಾವಾಗ ಡೈವರ್ಟ್ ಆಗ್ತಿರ್ತದ ಇನ್ಸ್ಟಾಗ್ರಾಮ್ ಕಡೆ, ಈ ಡೈವರ್ಷನ್ ತೊಗೊಂಡ್ಬಿಡು, ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್, A and B are the resonating or conical structures and C is the resonance hybrid. Some other examples we can give it. So these are the few examples which they have given it. First one is CO3 2-. This is the resonance structure, how it's been forming. Next comes the carbon oxygen bond lengths in the carbonate ion are actually equal due to the resonance. This is what the another resonance which will tell, right? Next comes the benzene, how the resonance is going to form here. Clear? This is how the resonance are going to form. Simple way. Yes, this is very simple way. ಸೊ ಬೇಕಂದ್ರೆ ಬಿಟ್ಬಿಡು ಇನ್ಸ್ಟಾಗ್ರಾಮ್ ಸ್ಕ್ರೋಲ್ ಮಾಡೋದು. ಅಂಬಾನಿ ಆಗೋದಿದೆ ಅಂದ್ರೆ ಸ್ಕ್ರೋಲ್ ಮಾಡೋದು ಬಿಟ್ಬಿಡ್ಬೇಕು, ತಿಳಿತಾ? ಇಲ್ಲಾಂದ್ರೆ ರಾಧಿಕಾ ಮರ್ಚೆಂಟ್ ಸಿಗೋದು ನಿನಗೆ. ರಾಧಿಕಾ ಮರ್ಚೆಂಟ್ ಬೇಕಂದ್ರೆ ಯು ಪೀಪಲ್ ನೀಡ್ ಟು ಸಿಟ್ ಅಂಡ್ ಸ್ಟಡಿ, ರೈಟ್? Radhika, he is telling me Instagram, how to leave the Instagram distraction. So I told him let him become Ambani, then he will become.
Yeah, who is asking?
Vikas.
Instagram delete ಮಾಡ್ಬಿಡಿ, ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಆಯ್ತಲ್ವಾ? ಹಾ, Instagram delete ಮಾಡ್ಬಿಡಿ.
ಓಕೆ, ತಿಳಿತಾ ಇಲ್ಲಿ ತನಕ? ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಿನೈಲ್ ಕ್ಲೋರೈಡ್. ಸೊ ಏನಾಗ್ತಿದೆ ಈಗ ವಿನೈಲ್ ಕ್ಲೋರೈಡ್ ನಲ್ಲಿ? ಸೇಮ್ ಅದೇ ತರ ಬಾಂಡಿಂಗ್. ಓಕೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಷ್ಟಿದೆ? ಆಕ್ಚುಲಿ ದೇ ಆರ್ ಹ್ಯಾವಿಂಗ್ 3 pairs of electrons here, right? So it's giving to the CH2. Clear? Reality checkup ಆಗ್ತಿದೆನಾ? Yes, this is how the reaction is going to form. Next comes the ionic bonding. Now everyone are clear how the covalent bonding is being done. And I will tell you one more thing about the covalent bonding also. Yes, Gopika Ma'am just came and went. ಸೊ ಈಗ ಕೋವಲೆಂಟ್ ಬಾಂಡಿಂಗ್ ನಲ್ಲಿ ಏನಪ್ಪ ಆಗ್ತಿದೆ? ಕೋವಲೆಂಟ್ ಬಾಂಡಿಂಗ್ ಮೀನ್ಸ್ ವಾಟ್? ಕೋವಲೆಂಟ್ ಬಾಂಡಿಂಗ್ ಇಸ್ ಆಕ್ಚುಲಿ ಅ ವೆರಿ ಸ್ಲೋ ಪ್ರೊಸೆಸ್. ಓಕೆ, ಕೋವಲೆಂಟ್ ಬಹಳ ಸ್ಲೋ ಪ್ರೊಸೆಸ್ ಇದೆ. ಯಾವ ತರ ಸ್ಲೋ ಪ್ರೊಸೆಸ್ ಅಂದ್ರೆ ಅದೇನ್ ಮಾಡುತ್ತಂದ್ರೆ ಫಸ್ಟ್ ಇಟ್ ವಿಲ್ ಗೋ. ಓಕೆ, ಕೋವಲೆಂಟ್ ಬಾಂಡಿಂಗ್ ಫಸ್ಟ್ ಅಲ್ಲಿ ಹೋಗುತ್ತೆ, ಅಲ್ಲಿ ಹೋಗಿ ಆ ಬಾಂಡ್ ಅನ್ನ ಮುರಿಯುತ್ತೆ ಅಂಡ್ ದೆನ್ ದೇ ವಿಲ್ ಫಾಂಡ್. ಓಕೆ, ಈಗ 3 ಫ್ರೆಂಡ್ಸ್ ಇದ್ದಾರೆ. 3 ಫ್ರೆಂಡ್ಸ್ ನಲ್ಲಿ ಥರ್ಡ್ ಫ್ರೆಂಡ್ ಏನಿದೆ ಅಲ್ಲ, ಥರ್ಡ್ ಫ್ರೆಂಡ್ ಇವು 2 ಫ್ರೆಂಡ್ಸ್ ಜೊತೆ ಕ್ಲೋಸ್ ಇರಲ್ಲ. ಓಕೆ, 2 ಫ್ರೆಂಡ್ಸ್ ಜೊತೆ ಕ್ಲೋಸ್ ಇರಲ್ಲ. ಥರ್ಡ್ ಪರ್ಸನ್ ಏನ್ ಮಾಡ್ತಾನಂದ್ರೆ ಥರ್ಡ್ ಪರ್ಸನ್ ಹೋಗಿ ಫಸ್ಟ್ ಉರಿ ಹಚ್ಬೇಕಲ್ಲ ಒಂದು ಹುಡುಗನಿಗೆ. ಸೊ ಅವ್ನಿಗೆ ಹೇಳ್ತಾನೆ ಶಿ ಇಸ್ ನಾಟ್ ಗುಡ್, ಶಿ ವಿಲ್ ಆಲ್ವೇಸ್ ಇಂಟರ್ಫಿಯರ್ ಇನ್ ಅದರ್ ಥಿಂಗ್ಸ್ ಇನ್ ಆಲ್ ದೋಸ್ ಸ್ಟಫ್ ಅಂತ ಹೇಳಿ ಸ್ವಲ್ಪ ಮುರಿಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾನೆ. ಓಕೆ, ಹಿ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಡೂಯಿಂಗ್ ದಟ್. ಮತ್ತೆ ಆಮೇಲೆ ಫುಲ್ ಜಗಳ ಆಗುತ್ತೆ ಇಬ್ಬರದ್ದು ನಡುವು. ಸೊ ಫುಲ್ ಜಗಳ ಆದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ, ಫುಲ್ ಜಗಳ ಪೂರ್ತಿ ಮಾಡಿದ ತಕ್ಷಣ ಅವ್ರದ್ದು ಬಾಂಡಿಂಗ್ ಮುರಿಯುತ್ತೆ. ಆಮೇಲೆ ಥರ್ಡ್ ಪರ್ಸನ್ ಏನದಲ್ಲ ಹೋಗಿ ಅವ್ರ ನಡು ಕುಂತ್ಬಿಡ್ತಾನೆ. ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ದ ಕೋವಲೆಂಟ್ ಬಾಂಡ್ ಇಸ್. ಯು ನೋ ಹೌ ದ ಬಿಗ್ ಪ್ರೊಸೀಜರ್ ಇಸ್ ದಟ್, ರೈಟ್? ಬಹಳ ದೊಡ್ಡ ಪ್ರೊಸೀಜರ್ ಇಲ್ಲ. ಬಟ್ ಅಯೋನಿಕ್ ನಲ್ಲಿ ಆ ತರ ಏನೂ ಇಲ್ಲ. ಅಯೋನಿಕ್ ನಲ್ಲಿ ಇಟ್ಸ್ ಲೈಕ್ ವಾಟ್, ಇನ್ಸ್ಟಂಟ್. I became friend. By I became friend. Like that. Easy way. Who are the friend? Who you people tell me? ಯಾರ್ ನಿಮ್ದ್ರಲ್ಲಿ ಯಾವ ತರ ಇದ್ದೀರಾ ನೀವು? ಕೋವಲೆಂಟ್ ಇದ್ದೀರಾ ಅಂಡ್ ಅಯೋನಿಕ್ ಬಾಂಡಿಂಗ್ ಇದ್ದೀರಾ ಅನ್ನೋದು ನೀವು ಹೇಳಿ. Who are covalent and who are ionic? Tell me in the chats. Next, till I explain, you people need to tell it in the chats now. Now, formation of the ionic bond. How the formation of the ionic bonds are happening? Now, formation of the ionic bond takes place between the metals and the non-metals by transfer of the electrons. L form agutte in between the metals and the non-metals. This both are going to form, and mainly it is happening because of the transfer of the electrons. It's happening because of the transfer of the electrons. Clear? Yes. Next steps which is involved in the formation of the ionic bond. First step is formation of a gaseous cations. First in formation of a gaseous cation. Clear? Equation what is going to form? A, which is in a gaseous form, in the ionic equilibrium, or it is also called as ionic equilibrium only, which will form A plus, that is going to be the gaseous, and 1 electron. It means what? It is donating. That is called as ionization energy. Next comes formation of gases of anions. Anions andre ಏನಪ್ಪ? Anions andre electron ತಗೋತಿದೆ. Okay, electrons ತಗೋತಿದೆ. ಇದು ಕೊಡ್ತಿದೆ, ತಗೋತಿದೆ. Okay, next here X, which is in the gaseous form, it has been taken the electron from here. It's been taken the electron from here. Electron ತಗೋದು ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ತಗೊಂಡ್ಬಿಡ್ತು electron ತಗೊಂಡು X minus, that is going to be the gaseous, means it has been taken the electron, gained the electron. Okay, so that is called as electron affinity. Na electron ಕೊಡ್ತಿದ್ದೇನೆ or like snatching the electron, it is called as electron affinity. Clear? Electron affinity ಅಂದ್ರೆ ಏನು? ನಾ electron ಯಾರೋ ಕಡೆಯಿಂದ ತಗೊಳ್ತಿದ್ದೇನೆ, I'm snatching it. That is what ionic bonding does. Ionic bond full arrogant ಇರುತ್ತೆ. ನೀ ನನಗೆ ಏನೋ ಕೊಡ್ತಿಲ್ಲಲ್ಲ, ನಾ ಇಸ್ಕೊಂಡ್ಬಿಡ್ತೇನೆ ಅದನ್ನ. ನೀನು ನಂಗೆ ನೋಟ್ಸ್ ಕೊಡ್ತೀರಾ, ನಾನು ಚೋರಿ ಮಾಡಿಬಿಡ್ತೇನೆ, ಇಲ್ಲ ನಾನು ಇಸ್ಕೊಂಡ್ಬಿಡ್ತೇನೆ ನೀನು ಹೇಳ್ದ. ಸೊ ಇದಕ್ಕೇನಂದ್ರೆ ಅಯೋನಿಕ್ ಬಾಂಡಿಂಗ್ ಅಂತ ಕರೀತಾರೆ. ಅದಕ್ಕೆ electron affinity is the name for that. Okay, next, packing of the ions of opposite charges to form the ionic solids. Like example A plus, that is X minus, which is going to be the grams, which will form AX, which is in the solid, plus the energy. Clear? That is called as what? Lattice energy. Means whatever this bond formation is happening, ionic bonding in ಆಗ್ತಿದೆ ಅಲ್ಲ, ಯಾವ ಎನರ್ಜಿ ಬೇಕಿದ್ದಕ್ಕೆ? lattice energy ಬೇಕು. ಅವಾಗ lattice energy means one electron is being taken from the snatching. Means ನಾನು ನಿನ್ ಕಡೆಯಿಂದ ಸ್ನ್ಯಾಚ್ ಮಾಡ್ತಿದ್ದೇನೆ ಎಲೆಕ್ಟ್ರಾನ್. ಇಲ್ಲಾಂದ್ರೆ ಎಕ್ಸಾಂಪಲ್, ನೀವನ್ನ ಕಲಿಸ್ತಿದ್ದೇನೆ, ಈಗ ನೀವು ಕಲಿತಿದ್ದೀರ ಅದನ್ನ, ರೈಟ್? You people are snatching the things. You people are snatching my notes and you people are studying. Clear? Done. This is the important concept which you people need to understand. Krita, ಇದು ಬಹಳ important too. Make sure you people will practice it. Next, this is how the rock salt structure has been formed. Simple way. Next, lattice enthalpy. So what is the meaning of a lattice enthalpy? On lattice enthalpy also most of the questions will come. NEET ನಲ್ಲಿ question ಕೇಳ್ತಾರೆ lattice enthalpy ಮೇಲೆ. Make sure to practice it clearly. Clear? Concept understanding perfect ಇರಬೇಕು. NEET perspective wise ಇಂದ lattice enthalpy ದಿಂದ one question short ಆಗಿ ಕೇಳ್ತಾರೆ. ಬಹಳ ಸಲ ಕೇಳಿದಾರೆ ಸಕಟು, ಆಯ್ತಾ? Now the lattice enthalpy of an ionic solid is defined as the energy required to completely separate 1 mole of a solid solid ionic compound into the gaseous consistent ions. So solid ದಿಂದ gaseous consistent ion convert ಮಾಡ್ಲಿಕ್ಕೆ ಯಾವ ತರ ಎನರ್ಜಿ ಬೇಕಲ್ಲ ಅದಕ್ಕೆ lattice enthalpy ಅಂತ ಕರೀತಾರೆ. ಕ್ಲಿಯರಾ? ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ lattice enthalpy of NaCl is 788 kilojoules per mole. ಸೊ ಎಷ್ಟಿದೆಪ್ಪ? 788 ಕಿಲೋ ಜೂಲ್ಸ್ ಪರ್ ಮೋಲ್ ಇದೆ. ಆಯ್ತಾ? ಸೊ NaCl ಇದು NaCl ಎಷ್ಟು ಎನರ್ಜಿ ಇದೆ? 788 kilojoules per mole ಇದೆ. ಓಕೆ, ಎಂಥಾಲ್ಪಿ, lattice enthalpy ಇದು. ಓಕೆ, this is the energy of the lattice enthalpy. This means what? 788 kilojoules of energy is required to separate 1 mole of solid of NaCl into 1 mole of sodium in the gaseous form and 1 mole of chloride to an infinite distance. It means what? 1 mole convert ಮಾಡ್ಲಿಕ್ಕೆ, ಸೊ ಇದೆರಡು ಪಾರ್ಟ್ ಮಾಡ್ಲಿಕ್ಕೆ, ಇವೆರಡು ಪಾರ್ಟ್ ಮಾಡ್ಲಿಕ್ಕೆ 1 ಮೋಲ್ದು. So how much energy is needed? It needs 788 kilojoules per mole is necessary. Per mole is necessary. Clear? Understood? ಒಂದು ನಿಮಿಷ. Yes. Clear everyone how the lattice enthalpy is being formed? To convert 1 mole into NaCl solid in the gas convert ಮಾಡ್ಲಿಕ್ಕೆ 1 mole ಇದ್ದಾಗ ಆ ಏನ್ ಎನರ್ಜಿ ಬೇಕಲ್ಲ lattice enthalpy ಅಂತ ಕರೀತಾರೆ. ಆಯ್ತಾ? Now this process involves both the attractive force between the ions of opposite charges like plus and minus combine ಆಗುತ್ತೆ. Okay, opposite charges attract ಆಗುತ್ತೆ. Then the solid crystal being 3 dimension, it is not possible to calculate the lattice enthalpy directly from the interaction of the forces of the attraction and the repulsion only. For that purpose, factors associated with the crystal geometry have to be included. This is the crystal geometry of a rock salt structure, that is NaCl. ಈ NaCl structures ನ ಹೇಗೆ, it is a crystal form. Okay, so ಈ ತರ ಅನ್ನ ಫೌಂಡ್ ಮಾಡ್ಕೊಂಡು ಈಸಿ ಆಗಿ lattice enthalpy ಅನ್ನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬಹುದು. ಆಯ್ತಾ? ಸೊ ದಿಸ್ ಇಸ್ 3D structure. Okay, 3D structure of a rock salt, that is NaCl. Next comes what? Bond parameters. So in bond parameters, we are going to learn about the bond length. So bond length ಹೇಗೆ calculate ಮಾಡಬೇಕು and what is the meaning of a bond length we need to understand. Now till now we have studied about the lattice enthalpy, we studied about the lattice energy, how the ionic bonding is happening, how the covalent bonding is happening. So where the electrons are getting shared, ಯಾವಾಗ double bond ಆಗುತ್ತೆ, ಯಾವಾಗ triple bond ಆಗುತ್ತೆ, ಅವನ್ನೆಲ್ಲ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡ್ವಿ. Right? Now let us go to the bond parameters. So in bond parameters, bond length, that is bond length is defined as the equilibrium distance between the nuclei of 2 bonded atoms in a molecule. 2 bonded atoms in a molecule. Okay, in a molecule nalli 2 bonded atoms in a bond ಆಗುತ್ತೆ. Clear? Now bond lengths are measured by spectroscopic or X-ray diffraction and the electron diffraction techniques, about which you will learn in the higher classes. Like example, you might learn it in the second PUC. Okay, now each atom of the bonded pair contributes to the bond length. In the case of covalent bond, the contribution from each atom is called as covalent radius of that atom. Okay, covalent radius, covalent bonding ಆಗ್ತದೆ, ಒಂದು ಏನ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, ಟ್ರಾನ್ಸ್ಫರ್ ಆಗುತ್ತೆ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್, ಅದಕ್ಕೆ ಏನ್ ಕರೀತಾರೆ? ಕೋವಲೆಂಟ್ ರೇಡಿಯಸ್ ಅಂತ ಕರೀತಾರೆ. ವಾಟ್ ದೇ ವಿಲ್ ಕಾಲ್? ಕೋವಲೆಂಟ್ ರೇಡಿಯಸ್. ಕ್ಲಿಯರ್? ಕ್ಲಿಯರ್? Next, the covalent radius is measured approximately as the radius of an atom's core, which is contact with the core of an adjacent atom in the bonded situation. So the covalent radius is half of the distance between the 2 similar atoms joined by the covalent bond. Like example, CC ಏನೋ ಬಾಂಡ್ ಆಗಿದೆಯಪ್ಪ, ಇಲ್ಲಿ ಏನೋ ಕೋವಲೆಂಟ್ ಬಾಂಡಿಂಗ್ ಆಗ್ತಿದೆ, ಕೋವಲೆಂಟ್ ಬಾಂಡಿಂಗ್ ಆಗ್ತಿದೆ ಇದ್ರದ್ದು, ಇವೆರಡು ಥರದ್ದು ಕೋವಲೆಂಟ್ ಬಾಂಡಿಂಗ್ ಆಯ್ತು. ಈ ಕೋವಲೆಂಟ್ ಬಾಂಡು ಹಾಫ್ ಡಿಸ್ಟೆನ್ಸ್. ಓಕೆ, ಹಾಫ್ ಡಿಸ್ಟೆನ್ಸ್ ಏನಾಗುತ್ತಲ್ಲ ಅವಾಗ ಕೋವಲೆಂಟ್ ರೇಡಿಯಸ್ ಅಂತ ತಿಳ್ಕೋಬಹುದು ಆಫ್ ದ ಕಾರ್ಬನ್, ಸಾರಿ ಆಫ್ ದ ಕಾರ್ಬನ್. ಓಕೆ, ಕ್ಲಿಯರ್? So this is called as a bond length. We will learn it in detail also now. Okay. So the bond length in the covalent bond molecule of AB. So same ಅದೇ ತರ ಏನು ಕಾರ್ಬನ್ ಕಾರ್ಬನ್ ಹೇಳ್ತಿಲ್ಲ, ಸಿಂಪಲ್ ಅದೇ ತರ ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇದೊಂದು A. Okay, think like any one element is there. This is one more element B. Okay, so ಈ ಒಂದು ಎಲಿಮೆಂಟ್ ಇದೊಂದು ಎಲಿಮೆಂಟ್. Okay, now central ಇಂದ. Okay, this is RA. This is the radius of a one element, covalent radius. but ಇನ್ನೊಂದು ಎಲಿಮೆಂಟ್ ಇದು covalent radius, half of. Okay, half of 1A, half of 1 more B. ಎರಡು ತರದ್ದು half of ಆಗುತ್ತೆ. Clear? That is called as covalent radius. Means what? Covalent radius, why it is important? It's important to bond. It's important for the bonding purpose. Clear? Now, in the same molecule, the van der Waals radius represents the overall size of the atom, which includes further the van der Waals radius in the half of the distance between the two similar atoms in the separate molecule in a solid. So the covalent and the van der Waals radii of the chlorine are dispersed in the figure 4.2. This is our 4.2. Here you can just observe the things. That is covalent and the van der Waals radii in the chlorine molecule. This is the chlorine molecules. Okay, the inner circles corresponds to the size of the chlorine atom and are van der Waals and the covalent radius respectively. These are the two things which you people need to understand. So ಎರಡು ಇದೆ. ಯಾವ ತರ ಆಗುತ್ತೆ ಇದ್ರದ್ದು 99 ಕೋವೆಲೆಂಟ್ ರೇಡಿಯಸ್ ಎಷ್ಟಿದೆ 99 pm. ಇನ್ನ ಒಂದ್ರದ್ದು ಎಲಿಮೆಂಟ್ ಇದು 198 pm ಇದೆ. ಮೀನ್ಸ್ ವಾಟ್ 99 like that, half. Okay, depends. ಇಲ್ಲಿ ಎಷ್ಟಿದೆ ತಿಳ್ಕೊಳ್ಳಿ, ಇಲ್ಲಿ 99 ಇದೆಯಪ್ಪ. ಓಕೆ, ಇಲ್ಲಿ 199 ಇದೆ. ಓಕೆ, ಎರಡರದ್ದು ಹೆಂಗಾಗುತ್ತೆ 99 and 199. Clear? Why we have to learn chemistry? Chini, we need to learn chemistry to be having a chemical reactions between us. No, we both have a chemical reactions now. Same like that, only with had to have a different people's case at chemical reactions. We need to learn chemistry for that. Okay. Next, conditions required for formation of the ionic bonds. Hegappa formation agutte ionic bond. Okay. Heg formation agutte ionic bond. That is, first one is low ionization energy of the cation. So ಹೇಗೆ condition required formation ಹೇಗಾಗುತ್ತೆ ionic bond ಇದು. So ಈಗ ನಾನು I am getting bonded with one element in the form of ionic bond, means strongest one, very easiest one. Okay, so ಹೇಗೆ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, ಕಂಡೀಷನ್ ಏನಿರುತ್ತೆ, ಲೋ ಅಯೋನೈಸೇಷನ್ ಎನರ್ಜಿ ಇರುತ್ತೆ cation ನಲ್ಲಿ. Okay, low ionization energy of the cation. Next comes high electron affinity of the anion. High electron affinity ಅಂದ್ರೆ ಏನು, ಸ್ನ್ಯಾಪ್ ಮಾಡ್ಲಿಕ್ಕೆ, ನಿನ್ ಕಡೆಯಿಂದ ನಾನು ಇಲೆಕ್ಟ್ರಾನ್ ತಗೊಳ್ಳಿಕ್ಕೆ ಫುಲ್ ಎನರ್ಜಿ ಇದೆ ನನಗೆ. ಓಕೆ, ಐ ಕ್ಯಾನ್ ಜಸ್ಟ್ ಫೈಟ್ ವಿತ್ ಯು ಪೀಪಲ್ ಟು ಟೇಕ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಫ್ರಮ್ ಯು. ಓಕೆ, that is one. Because we have subject in MBBS biochemistry. Oh, very good, Guru Raj, you are going to study MBBS biochemistry. Very good. So next, high lattice energy ಇರಬೇಕು. high lattice energy ಅಂದ್ರೆ ಏನು, ಎನರ್ಜಿ ಫುಲ್ ಜಾಸ್ತಿ ಇರಬೇಕು ತಗೊಳ್ಳೋದು ಮುಂದೆ. ಓಕೆ, ಇದೇನು ಎಲೆಕ್ಟ್ರಾನ್ ಸ್ನಾಚ್ ಮಾಡ್ತಿರ್ತದಲ್ಲ, ಎಲೆಕ್ಟ್ರಾನ್ ಅಫಿನಿಟಿ ಅವಾಗ ಎನರ್ಜಿ ಇರಬೇಕಲ್ಲ ಜಾಸ್ತಿ. ಎನರ್ಜಿನೇ ಇದ್ರಲಿಲ್ಲ ಅಂದ್ರೆ ಹೇಗೆ ಫೈಟ್ ಮಾಡುತ್ತೆ, ರೈಟ್? ಯು ಪೀಪಲ್ ಆರ್ ಫೈಟಿಂಗ್ ಇಫ್ ಯು ಪೀಪಲ್ ಹ್ಯಾವ್ ಅ ಎನರ್ಜಿ, ರೈಟ್? ಎನರ್ಜಿ ಇದ್ರೆ ಅಷ್ಟೇ ಫೈಟ್ ಮಾಡ್ತಾರಲ್ಲ. Okay, next covalent bonding. Okay, next comes what? Covalent bonding. Here also I am just going fast here. Why? Because we have learnt it already. Okay, so simple points ಮಾಡಿ ಹಾಕಿರೋದು. So covalent bond is formed between the two non-metals by sharing of the electrons. So covalent bonding ಯಾವ ತರ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, they will be it will happen in between the two non-metal by sharing the electrons. So ionic bonds ಅಂದ್ರೆ ಏನು, ionic bonds ಅಂದ್ರೆ ಜಗಳಾಡಬೇಡ್ರೋ ಹುಡುಗರೇ, ಜಗಳಕ್ಕೆ ಹೋಗ್ಬೇಡ್ರಿ. ಇಲ್ಲಿ ಕ್ಲಾಸ್ ಕಲಿಯಕ್ಕೆ ಬಂದಿದ್ದಾರೆ, ಕೊಂಡು ಜಗಳಾಡ್ತಾರಲ್ಲ. ಓಕೆ, ಸೊ ಹಿಯರ್ ವಾಟ್ ಯು ಪೀಪಲ್ ನೀಡ್ ಟು ಡೂ, ಕೋವಲೆಂಟ್ ಬಾಂಡಿಂಗ್ ನಲ್ಲಿ ಯಾವಾಗಲೂ ಬಾಂಡಿಂಗ್ ಆಗೋದು ನಾನ್ ಮೆಟಲ್ಸ್ ಜೊತೆ. ಓಕೆ, ನಾನ್ ಮೆಟಲ್ಸ್ ಜೊತೆ ಬಾಂಡ್ ಆಗುತ್ತೆ. ಅಯೋನಿಕ್ ಯಾವಾಗಲೂ ಮೆಟಲ್ಸ್ ಮತ್ತೆ ನಾನ್ ಮೆಟಲ್ಸ್ ಜೊತೆ ಆಗುತ್ತೆ, ಆಯ್ತಾ? ಸೊ ನಾವು ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರ್ಸ್ ವಿಚ್ ಪಾರ್ಟಿಸಿಪೇಟ್ ಇನ್ ಬಾಂಡಿಂಗ್ ಆರ್ ಕಾಲ್ಡ್ ಬಾಂಡ್ ಪೇರ್ಸ್. ಓಕೆ, ಯಾವ್ಯಾವ ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರ್ಸ್ ಬಾಂಡ್ ಆಗುತ್ತೆ ಮುಂದೆ ಪೇರ್ ಆಗುತ್ತಲ್ಲ ಅವಕ್ಕೆಲ್ಲ ಹೆಂಗ್ ಕರೀತಾರೆ, ಬಾಂಡ್ ಪೇರ್ಸ್ ಅಂತ ಕರೀತಾರೆ. ನೆಕ್ಸ್ಟ್, ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರ್ಸ್ ವಿಚ್ ಡು ನಾಟ್ ಪಾರ್ಟಿಸಿಪೇಟ್ ಇನ್ ಬಾಂಡಿಂಗ್ ಆರ್ ಕಾಲ್ಡ್ ಆಸ್ ಲೋನ್ ಪೇರ್ಸ್. ಯಾವ ಈಗ ಬಾಂಡ್ ಆಗುತ್ತೆ ಮುಂದೆ ಯಾವ ಪಾರ್ಟಿಸಿಪೇಟ್ ಮಾಡಲ್ಲ, ಲೋನ್ ಪೇರ್ಸ್ ಪಾರ್ಟಿಸಿಪೇಟ್ ಮಾಡಲ್ಲ. ಕ್ಲಿಯರಾ? Next comes, there would be a single or double or triple bond between the two elements depending on the number of the electrons being shared. That's what I told you. ನೀವು 2 ಕೊಡ್ತಿದ್ರೆ ಸಿಂಗಲ್ ಆಗುತ್ತೆ, 3 ಕೊಡ್ತಿದ್ರೆ ಡಬಲ್ ಆಗುತ್ತೆ. ಈ ತರ ನೀವು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೇಕು, ಆಯ್ತಾ? ಕ್ಲಿಯರ್? Next, we are going to go for the valence shell electrons. We are going to go for what? Valence shell electrons. Clear? We have still lots of things to learn. Okay. So first is about it is also called as VSEPR also. Valence shell gain anta karitare. VSEPR antanu karitare. Okay. Now, the shape of the molecule is determined by the repulsion between all the electron pairs present in the valence shell. So, whatever the shape of the molecule is going to be determined, that all is going to depend on the repulsion between all the electron pairs. So, electron pair repulsion hegagutte, it is like how it's going to be like present in the valence shell. Means outermost shell nalli ಎಷ್ಟು electrons ಇದೆ ಅಲ್ಲ ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ how the structure is going to form. ಓಕೆ, ಯಾವ್ದಾದ್ರು ಎಲಿಮೆಂಟ್ ಸ್ಟ್ರಕ್ಚರ್ ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ, ಅದು ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ. ಬ್ಲಾಕ್ ಹಿಮ್ ಮ್ಯಾಮ್, ಹೂಮ್ ವಿ ಶುಡ್ ಬ್ಲಾಕ್ ಅಪ್ಪ? ವಿಕಾಸನ್ ಬ್ಲಾಕ್ ಮಾಡ್ಬೇಕಾ? ಏನ್ ವಿಕಾಸ್, ಯು ಆರ್ ಜೂನಿಯರ್ ಅಂಡ್ ಯು ಆರ್ ರ್ಯಾಗಿಂಗ್ ಫಾರ್ ದ ಗುರುರಾಜ್ ಓನ್ಲಿ. ಯು ಶುಡ್ ನಾಟ್ ಡೂ ಲೈಕ್ ದಟ್, ನೋ. ಸೊ ಹೀಗೆ ಮಾಡಿದ್ರೆ ಹೇಗಪ್ಪ ಆಗುತ್ತಾ? ಹಾ, ಓಕೆ, ಯು ಪೀಪಲ್ ಟೋಲ್ಡ್ ಸಾರಿ, ಗುರುರಾಜ್ ಹಿ ಟೋಲ್ಡ್ ಯು ಸಾರಿ, ಇಟ್ಸ್ ಡನ್. Yes. First point is the shape of the molecule is determined by the repulsion between the all. Next comes the order of the repulsion. That is lone pair is going to be the more, then the lone pair, then the bond pair, then comes the bond pair. Clear? Next, repulsion among the bond pairs is directly proportional to the bond order. So whatever the repulsion of the bond pairs are happening, that is directly proportional to what? Bond order. It's directly proportional to the bond order and the electronegativity difference between the central metal and the other atoms. Clear? Now, how to determine the shape of the molecules by using ಹೇಗಪ್ಪ shape find ಮಾಡಬೇಕು VSEPR theory ಇಂದ, ಮತ್ತೆ ಅದರದ್ದು ಏನು ಲಿಮಿಟೇಷನ್ಸ್ ಇದೆ ಅನ್ನೋದು ಈಗ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳೋಣ, ಆಯ್ತಾ? ಸೊ ಫಸ್ಟ್ ಇಸ್ ವಾಟ್? ಸೊ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಎಕ್ಸ್ ಬೈ ಯೂಸಿಂಗ್ ದ ಫಾಲೋವಿಂಗ್ ಮೆಥಡ್. ನಾವು ಫಾರ್ಮಲ್ ಚಾರ್ಜಸ್ ಹೇಗೆ ಫಾರ್ಮುಲಾ ಇತ್ತಲ್ಲ, ಸೇಮ್ ಅದೇ ಥರ ವಿ ಹ್ಯಾವ್ ಇವನ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಸ್ಟ್ರಕ್ಚರ್ ವಿ ಹ್ಯಾವ್ ಒನ್ ಸಿಂಪಲ್ ಫಾರ್ಮುಲಾ. ಓಕೆ, ಇದನ್ನು ಫೈಂಡ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ ಸ್ಟ್ರಕ್ಚರ್ ಡ್ರಾ ಮಾಡಲಿಕ್ಕೆ ಈಸಿ ಆಗುತ್ತೆ. ಸೊ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ವಾಟ್? ನಂಬರ್ ಆಫ್ ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಫ್ ದ ಸೆಂಟ್ರಲ್ ಆಟಮ್. ಓಕೆ, ಸೆಂಟ್ರಲ್ ಆಟಮ್ ನಲ್ಲಿ ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಷ್ಟಿದೆ? ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್ O3 ಇದೆ. ಆಕ್ಸಿಜನ್ ನಲ್ಲಿ ಸೆಂಟ್ರಲ್ ಆಟಮ್ ನಲ್ಲಿ ಎಷ್ಟಿದೆ? 2 ಇದೆ. ರೈಟ್, 2 ಆರ್ ದ number of valence electrons at the central atom. Clear? Next, outermost shell ಅಲ್ಲಿ ಎಷ್ಟು electrons ಇದೆ ಅದಕ್ಕೆ valence electrons ಅಂತ ಕರೀತಾರೆ. I am repeating it again and again. One second guys. Next, plus number of other atoms. So ಎಷ್ಟು other atoms ಇದೆ ಅದನ್ನ ಬರಿಬೇಕು. Plus the negative charge on the molecule. Negative charge ಎಷ್ಟಿದೆ? In case it's having a 2 electrons, it means what? I have taken the 2 electrons from someone. So ಅದನ್ನು ಬರ್ಕೋಬಹುದು. Like NO2 minus 2. ಅದರ minus 2 is the negative charge on the molecule. Minus positive charge on the molecule. Positive charge ಎಷ್ಟಿದೆ ಅದನ್ನು ಬರ್ಕೋಬಹುದು, ಆಯ್ತಾ? Now use this chart to find the shape. Now this is the chart which we are going to learn it and it's very very important. Okay, ಫಸ್ಟ್ ಒನ್ ಏನು? ಇದೆಲ್ಲ ಎಕ್ಸ್ ಇರೋದೆಲ್ಲ ನಂಬರ್, ಮೀನ್ಸ್ ಎಷ್ಟಿದೆ ಅನ್ನೋದು. ಓಕೆ, ಶೇಪ್ ಇದು, ಆಮೇಲೆ ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅದ್ರ ಪ್ರಕಾರ. ಓಕೆ, 2 ಇಸ್ ದ ಲೀನಿಯರ್, 2 electrons ಇದ್ರೆ ಲೀನಿಯರ್ ಮೀನ್ಸ್ ವಾಟ್? ಇಫ್ ಇಟ್ ಇಸ್ x means what? X means what? This has been calculated one. Okay, calculated one idu. So 2 idre linear irutte. Linear idre example Hg ಮತ್ತೆ Cl2 or BeCl2 ಅಂತ examples ತಗೋಬಹುದು. ಮ್ಯಾಮ್ ನಿಮ್ದು ದೊಡ್ಡ ಮನಸ್ಸು, ಥ್ಯಾಂಕ್ ಯು. ಎಸ್, ನನ್ನ ದೊಡ್ಡ ಮನಸ್ಸಪ್ಪ, ಭಾಳ ದೊಡ್ಡ ಮನಸ್ಸಿದೆ ನಂದು. So next comes the 3. X is going to be the 3. More idre, in case it's having a 3 has its VSEPR, then it's going to be the triangular planar. The examples we can take it as BF3. BF3 structure ಹೀಗಿರುತ್ತೆ ಈ ತರ, ಆಯ್ತಾ? Next 3 again angular, that is SnCl2 NO2. 4 andre tetrahedral irutte. 4 means it is going to be the tetrahedral, so that will be CH4 BF4 minus. So examples ಮಾಡ್ಕೋಬೇಕಂದ್ರೆ we'll do solve the examples also now. If you people want examples, one solve ಮಾಡಿ ತೋರಿಸ್ಬಿಡ್ತೇನೆ so that it will be easy to understand also for you people. Okay, ಯಾವ example ತಗೊಳ್ಳೋಣ? We'll take a triangular planar. BF3 ತಗೊಂಡ್ಬಿಡೋಣ. Okay, BF3 ತಗೊಳ್ಳೋಣ. So X is equal to what? X is equal to number of valence electrons at the central atom. B central atom ಎಷ್ಟಿದೆ? B central atom ಎಷ್ಟಿದೆ ಅನ್ನೋದು ಬರಿಬೇಕು. 2 electrons ಅಂತ ಬರ್ಕೊಂಡ್ವಿ, right? Next comes what? Number of other atoms. Number of other atoms plus number of the other atoms are how many? 3 plus negative charges on the molecule. Negative charges ಎಷ್ಟಿದೆ ಅಪ್ಪ? BF3 ಅಂದ್ರೆ -3 ಇರುತ್ತೆ negative charges. So, right, -3. Next, positive charges on the molecule, it's 1. Then how much it will be? Just think it out. 3, 4, 5, 6. So 3, 4, 5. 5 minus 3 ಎಷ್ಟಾಗುತ್ತಪ್ಪ? 2. 2 plus 1, 3. Right? Is it correct? Yes, it's 3. Right? 3 ಆಗುತ್ತೆ. 3 is actually called as what? Triangular planar. Triangular planar. ಈ ತರ ಸಾಲ್ವ್ ಮಾಡಬೇಕು ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಫಾರ್ಮುಲಾ. ಎಕ್ಸಾಂಪಲ್ ಅನ್ನು ಸಾಲ್ವ್ ಮಾಡಿದೆ. ಇದೇ ತರ ನೀವು ಎಲ್ಲಾ ತರದ ಎಕ್ಸಾಂಪಲ್ ಸಾಲ್ವ್ ಮಾಡಿ. ಎಕ್ಸಾಂಪಲ್ಸ್ ಆಲ್ರೆಡಿ ಕೊಟ್ಟಿದ್ದೇವೆ ಇಲ್ಲಿ. ಸೊ ಎಕ್ಸಾಂಪಲ್ಸ್ ಅನ್ನ ಈಚ್ ಅಂಡ್ ಎವ್ರಿ ವಾಟ್ ಎವರ್ ದ ಎಕ್ಸಾಂಪಲ್ಸ್ ನಾವು ಕೊಟ್ಟಿದ್ದೇನಲ್ಲ ಕುಂತು ಸಾಲ್ವ್ ಮಾಡ್ಬೇಕು ನೀವು, ಆಯ್ತಾ? ಸೊ ಇದನ್ನ ಮಿಸ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಯು ಪೀಪಲ್ ವಿಲ್ ನಾಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಎನಿಥಿಂಗ್ ಫ್ರಮ್ ದಿಸ್ ಚಾಪ್ಟರ್, ಆಯ್ತಾ? So next comes 4, that is tetrahedral, that will be example as CH4 BF4 minus. Next comes the trigonal bipyramidal, that is 4 again, that is NH3 PlCl3. Next comes the angular, that is H2O. Next comes the 5 trigonal bipyramidal, 5 again irregular tetrahedral, 5 again T-shaped, 5 again linear. So these are the few examples which you people can understand. Done. We have 6 means octahedral, 6 means square pyramidal also, and 6 means square planar also. Means ಎಲ್ಲದಕ್ಕೂ different examples ಇರುತ್ತೆ. Clear? So when you people will start solving it by using the formula, ಅವಾಗಷ್ಟೇ ತಿಳಿಯೋದು ನಿಮಗೆ, ಆಯ್ತಾ? Next, Fazan's rule. Let's move to the Fazan's rule now. Fazan's rule ಏನು ಕಲಿತೀರಾ? It accounts for the covalent character in ionic compounds. It accounts for covalent character in an ionic compound. Means what? Covalency is the favored by. It's favored by what? Smaller cation, larger anion, and a large charge on either ion. Large charge on the either ion. Black side alli explain ಮಾಡಿ please. Black side alli na. Which is the black side pa? Black side ಅಂದ್ರೆ ಇದಾ? ಶೇಪ್ ಇದು ಶೇಪು ಇದು ಎಕ್ಸಾಂಪಲ್. ಯಾವ ಬ್ಲಾಕ್ ಸೈಡ್ ಅಪ್ಪ ಗುರುರಾಜ? Yes, Fazan's rule ಅಂದ್ರೆ it accounts for the covalent character in ionic compound. Covalency is favored by smaller cation, then the large anion, and the large charge on the either of the ion. ಇವೆರಡರಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು larger ion ಅಂತ ಇರಬೇಕು. ಈ ಸರಿ ವೈವಾ ಅಲ್ಲೇ ಮ್ಯಾಮ್ ಅಂತವ್ರೆ. ಓಕೆ, ವಾಟ್ ಇಸ್ ವೈವಾ? ನಂಗೆ ತಿಳಿಲಿಲ್ಲಪ್ಪ ಅಧ್ಯಕ್ಷನಿ. So next, dipole moment. Let's learn about the dipole moment. Dipole moment ಮೇಲೆ short question ಕೇಳ್ತಾರೆ. Important for NEET. Okay. Dipole moment of any bond is product of the new positive or the negative charge and the distance between the two charge ends, that is bond length. That is going to be what? Dipole moment is also considered as a small m. That is equal to electric charge, that is electric charge into the distance, and the dipole moment is measured in the dB unit, that is going to be the D. So ಯಾವ ತರ unit ಇದೆ dipole moment is dB unit, that is going to be the D. Now dipole moment of the molecule is vector addition of all the individual bond moments. It's going to be what? Vector addition. Okay, dipole moment ನಲ್ಲಿ ಏನೇನು ನೆನಪಿಟ್ಕೋಬೇಕು? It's a vector position and its unit is going to be the dB unit, and the formula is going to come what? M is equal to E into D. Okay, M is equal to E into D. So ಇದನ್ನಷ್ಟು ನೀವು ನೆನಪಿಟ್ಕೋಬೇಕು. ಸೊ ನನಗೆ ಡ್ರಾನೇ ಮಾಡ್ಲಿಕ್ಕೆ ಬರಲ್ಲಪ್ಪ, ಇದು ಈಗ ಹಾಕಬೇಕು. 1 second guys. Yes, done. Clear? Yes. Next comes the percentage ionic character. How to find the percentage ionic character, and this formula is going to help us a lot. Idr melenu question kelಬಹುದು. This is also important. Clear? The percentage of the ionic character is equal to observed dipole moment divided by accepted dipole moment. Observation ಮಾಡಿದಾಗ ಯಾವ ತರ dipole moment ಬಂದಿದೆ and accepted dipole moment. Accept ಮಾಡಬಹುದು. In case if we experimented it, ಎಷ್ಟಪ್ಪ ಬರ್ಬೋದು, that is called as accepted one. Okay? Into 100. So that is what the formula to find the percentage of the ionic character. Percentage of the ionic character. Clear? Next comes the the hydrogen bonding. Okay, hydrogen bonding ಮೇಲೆ ಬಹಳ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ ಆಯ್ತಾ. ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ಇಸ್ hydrogen bond is an electronic attractive force between the covalently bonding hydrogen atom of one molecule or a part of the molecule and an electronegative atom such as FON. These are electronegative, means what? Always it will be taking the electrons from someone. Okay, and of another molecule, that is intermolecular hydrogen bonding, or another part of the same molecule, that is intramolecular hydrogen bonding. That is going to be the intramolecular hydrogen bonding. Now next comes intermolecular hydrogen bonding will increase the boiling point. It will increase the boiling point. Intermolecular hydrogen bonding ಏನಿದೆ ಅಲ್ಲ ಅದರದು ಇನ್ಕ್ರೀಸ್ ಮಾಡುತ್ತೆ. ಏನು ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಕೊಂತ ಹೋಗುತ್ತೆ. ಯಾವಾಗ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ಆಗ್ತಿರುತ್ತಲ್ಲ ಅವಾಗೆಲ್ಲ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಜಾಸ್ತಿನೇ ಇರುತ್ತೆ ಆಯ್ತಾ. ಅಂಡ್ ದ ಕಂಪೌಂಡ್ ಆಲ್ಸೋ ಇಟ್ಸ್ ಅ ವಾಟರ್ ಸಾಲ್ಯುಬಿಲಿಟಿ. ಇಟ್ಸ್ ಅ ವಾಟರ್ ಸಾಲ್ಯುಬಲ್ ಈಸಿಲಿ. ಓಕೆ, ಇಟ್ಸ್ ಅ ವಾಟರ್ ಸಾಲ್ಯುಬಿಲಿಟಿ ಈಸಿಲಿ. ಪ್ರಕಾಶ್ ಈಗ ಬಂದಪ್ಪ. So intermolecular hydrogen bonding will decrease the boiling point of the compound, also its water solubility. Clear? Next comes what? This is how it's been forming. This is the hydrogen bond. The hydrogen bond 3D structure is okay. This is the hydrogen bond. This is the covalent bond which has been forming here. So how the oxygen is getting, means oxygen ಏನidella ಇದು central metal atom ಇದೆ, ಇವು hydrogens ಇದೆ. So hydrogen ನಡುವೆ ಏನಿದೆ covalent bonding ಇದೆ easy ಆಗಿ. So this is getting bonded with one more H2O, that is oxygen, hydrogen and hydrogen. So this bonding is actually called as what? Hydrogen bond. So in between two water molecules, if the bond is getting formed, that is called as hydrogen bond. ಆಯ್ತಾ, ಎರಡು water molecules ಇದೆ, ಅದು ಎರಡು ಬಾಂಡ್ ಆಗ್ತಿದೆ with the help of the covalent bond, that is called as hydrogen bonding. Okay, next comes what? Valence bond theory. So valence bond theory alli VBT, this is also very important concept. So VBT ana understand ಮಾಡ್ಕೊಳ್ಳೋಣ. Let us understand VBT. Yes. So the covalent bond is formed by overlapping of valence shell atomic orbital of the two atoms having the unpaired electrons. So whenever the covalent bond is being formed by overlapping the valence shell atomic orbital, then those two atoms will have what? It will have a unpaired electrons. Clear? Next, there is a maximum electron density between the bonding atoms. So there will be what? Maximum bonding between the maximum electron density irutte in between the bonding atoms. ಯಾವುದು ಒಂದು ಎರಡು ಬಾಂಡ್ ಆಗ್ತಿದೆ ಅಪ್ಪ, ಆ ಬಾಂಡಿಂಗ್ ಏನಾಗ್ತಿದೆ ಅಲ್ಲ, ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್ ಆಕ್ಸಿಜನ್ ಇಸ್ ಗೆಟಿಂಗ್ ಬಾಂಡೆಡ್ ವಿತ್ ದ ಹೈಡ್ರೋಜನ್. ಯಾವ ಬಾಂಡ್ ಆಗ್ತಿದೆ? ಕೋವಲೆಂಟ್ ಬಾಂಡಿಂಗ್ ಆಗ್ತಿದೆ ಹೈಡ್ರೋಜನ್ ಮತ್ತೆ ಆಕ್ಸಿಜನ್ ಜೊತೆ. ಸೊ ಆ ಬಾಂಡಿಂಗ್ ಆಗೋದ್ ಮುಂದೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಇರಬೇಕು. ಓಕೆ, ಮ್ಯಾಕ್ಸಿಮಮ್ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಇರಲೇಬೇಕು ಅಂದ್ರೇನೆ ಬಾಂಡ್ ಆಗೋದು ಆಯ್ತಾ. ನೆಕ್ಸ್ಟ್, ಗ್ರೇಟರ್ ದ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಆಫ್ ದ ಅಟಮಿಕ್ ಆರ್ಬಿಟಲ್ ಹೈಯರ್ ಇಸ್ ದ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ದ ಕೆಮಿಕಲ್ ಬಾಂಡ್. ಸೊ ಯಾವ್ದು ಗ್ರೇಟರ್ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಜಾಸ್ತಿ ಇದ್ರೆ, so atomic orbital will be having a higher strength irutte, means these all will be included in the ionic bonding itself, because ionic bonding is having a strongest one, right? Next, the bond formed by the lateral overlap of the two atomic orbitals, which is having a maximum overlapping on both the sides of the line connecting to the centers of the atoms, is called a pi bond. Okay, concentrate everyone. The bond formed by lateral overlap, example illu ide. So this is actually called as a lateral overlap. Means ಏನು, ನಿಂತುಕೊಂಡು overlap ಮಾಡ್ತಿದೆ. We are hugging each other. Hugging each other is actually called as what? Lateral. That is pi bond ಅಂತ ತಿಳ್ಕೊಂಬಿಡಿ ಆಯ್ತಾ. Pi bonding ಅಂದ್ರೆ hugging. Pi bonding is a hugging. This means what? This is sleeping and hugging. This is sleeping and hugging. Okay. So ಇಲ್ಲಿ ನೋಡಿ, concentrate ಮಾಡಿ. The two atomic orbitals having a maximum overlapping on both the sides of the line connecting the center of the atoms is called as pi bond. And a pi bond possesses a plane and a symmetry, often referred to as a nodal plane. It is also referred to as a nodal plane also. Okay, this is called as a pi bond. Clear? So this is called as a sigma bond. This is called as sigma bond. Means sigma bond is a head to head overlap. Okay, head to head overlap is called as sigma bond. And if in case straight lateral overlap is actually called as what? Pi bonds. I'll write it down here. Lateral overlap again ಕರೀತಾರೆ, pi bond ಅಂತ ಕರೀತಾರೆ. Lateral pi bond. If in case they are head to head ಇದ್ರೆ ಏನ್ ಕರೀತಾರೆ? ಸಿಗ್ಮಾ ಬಾಂಡ್. ಕ್ಲಿಯರಾ? ಸಿಗ್ಮಾ ಬಾಂಡ್. Next comes alpha bond when covalent bond is formed by overlapping of an atomic orbitals along with the same axis. Then it is called as sigma bond. Such type of a bond is symmetrical about the line joining the two nuclei. Example, SS overlapping. Here you can just observe SS overlapping. That is, here one S is there. It is one head, means head to head connected. So head to head got connected. It is forming one bond. Clear? Next comes SP overlapping. S ಮತ್ತೆ S shell ಮತ್ತೆ P shell overlap ಮಾಡ್ತಿದೆ. So you can just observe S is having single electron. You people know already. So ಇದಕ್ಕೆ ಇದೆ double ಇದೆ. So this is also happening head to head. That is also called as what? Alpha bond. Sigma bond. So next comes PP overlapping. PP overlapping is also happening like this itself. So it's called as what? Sigma bond. Clear everyone? Yes. Clear? Yes. Pi bond, this type of a bond is formed by sidewise or a lateral overlapping. That is what? Lateral overlapping or a sidewise overlapping is called as pi bonds. So this is how the lateral one it's happening. Nintkondo, that is called as lateral overlapping or a sidewise overlapping. Okay. Now strength of the bond depends on the extent of the overlapping of a half-filled atomic orbitals. Depends on half-filled electronic means half-filled andre if in case the octet is actually we need 8. ಓಕೆ 8 ಬೇಕಿದೆ ನನಗೆ. ನಾ ಅಂಬಾನಿ ಆಗ್ಲಿಕ್ಕೆ 8 ಬೇಕಿದೆ. ನಂಗೆ 8 ಇಲ್ಲಪ್ಪ, ನನ್ನ ಕಡೆ ಅರ್ಧ ಇದೆ. ಲೈಕ್ 4 ಐ ಆಮ್ ಹ್ಯಾವಿಂಗ್ ಇಟ್. ಓಕೆ, ಯು ಪೀಪಲ್ ಆರ್ ಹ್ಯಾವಿಂಗ್ ಅ 4 electrons. ಓಕೆ, ನಾ ಇಫ್ ಇನ್ ಕೇಸ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ಅ 4 electrons, that is called as half filled. ಕ್ಲಿಯರ್? ಸೊ ಅದಕ್ಕೆ ಏನ್ ಕರೀತಾರೆ ಇಲ್ಲಿ? ಹಾಫ್ ಫಿಲ್ಡ್ ಅಟೋಮಿಕ್ ಆರ್ಬಿಟಲ್ ಇದ್ರೆ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಏನೇ ಸಾಕು. ದ ಎಕ್ಸ್ಟೆಂಟ್ ಆಫ್ ದ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಇಸ್ ಬಿಟ್ವೀನ್ ದ ಟೂ ಆಟಮ್ಸ್ ಇಸ್ ಆಲ್ವೇಸ್ ಗ್ರೇಟರ್. ದ ಎಕ್ಸ್ಟೆಂಟ್ ಮೀನ್ಸ್ ವಾಟ್ ಎವರ್ ದ ಟೂ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್ ಇಸ್ ಆಲ್ವೇಸ್ ಗ್ರೇಟರ್. ಯಾವಾಗಲೂ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ವೆನ್ ದೇರ್ ಇಸ್ ಅ ಎಂಡ್ ಟು ಎಂಡ್ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಆಫ್ ದ ಆರ್ಬಿಟಲ್ಸ್, ದೆನ್ ವೆನ್ ದೇರ್ ಇಸ್ ಅ ಸೈಡ್ ವೈಸ್ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಆಫ್ ದ ಆರ್ಬಿಟಲ್ಸ್, hence S bond is always stronger than the P bond. Clear? So S bond is always stronger because it's slidewise only it is getting overlapped. No, it's not at P. Sometimes it will become lateral, sometimes it will be sleeping and taking overlapping. So depends on that. Okay, depends on that. So always the S is the biggest one compared to the P. Yes, I will give the break, Amma. We will finish this and then I will give you a break. Okay. Then the average distance between the nuclei of the two bonded atoms in a molecule is called as bond length, and the energy required to break one molecule of the bonds of particular type in a gaseous state is called as bond energy. Is called as bond energy or bond strength. Okay, bond energy or bond strength. Concentrate the average distance between the nuclei of the two bonded atoms. To average distance ಇದೆ ಎರಡು ತರದ್ದು ಬಾಂಡ್ ಆಗ್ಲಿಕ್ಕೆ. ಓಕೆ, ಎರಡು ತರದ್ದು ಬಾಂಡ್ ಆಗ್ಲಿಕ್ಕೆ ಯಾವ್ದು average distance ಇದೆ ಅಲ್ಲ, ಅದಕ್ಕೆ ಏನ್ ಕರೀತಾರೆ? ಬಾಂಡ್ ಲೆಂತ್ ಅಂತ ಕರೀತಾರೆ. ಅದಕ್ಕೆ ಏನ್ ಕರೀತಾರೆ? ಬಾಂಡ್ ಲೆಂತ್. Okay, or it is also called as the energy. Okay, so the average distance between the nuclei of the nuclei, average distance ಎರಡು ಎಲಿಮೆಂಟ್ಸ್ ಏನ್ ನ್ಯೂಕ್ಲಿಯರ್ ಡಿಸ್ಟೆನ್ಸ್ ಏನಿದೆಯಲ್ಲ ಅದಕ್ಕೆ ಬಾಂಡ್ ಲೆಂತ್ ಅಂತ ಕರೀತಾರೆ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ದ ಎನರ್ಜಿ ರಿಕ್ವೈರ್ಡ್ ಟು ಬ್ರೇಕ್ 1 mole ಆಫ್ ಬಾಂಡ್. ದ ಎನರ್ಜಿ ಏನ್ ಬೇಕಲ್ಲ ಬ್ರೇಕ್ ಮಾಡ್ಲಿಕ್ಕೆ, ಯಾರ್ದೋ ಒಂದು ಬ್ರೇಕಪ್ ಮಾಡ್ತಿದ್ದೇವೆ ನಾವು. ಓಕೆ, ಆ ಹುಡುಗ ಹುಡುಗಿ ಏನ್ ಬ್ರೇಕಪ್ ಮಾಡ್ತಿದ್ದೇವಲ್ಲ ಅದಕ್ಕೊಂದು ಎನರ್ಜಿನೂ ಬೇಕಲ್ಲ. ಯಾವ ಥರ್ಡ್ ಪರ್ಸನ್ ಏನ್ ಬ್ರೇಕ್ ಮಾಡ್ತಿದಾರಲ್ಲ ರಿಲೇಶನ್ಶಿಪ್ ಅನ್ನ, ಸೊ ಬ್ರೇಕ್ ಮಾಡ್ಲಿಕ್ಕೆ ಏನ್ ಎಫರ್ಟ್ಸ್ ಹಾಕ್ಬೇಕಲ್ಲ, ಏನ್ ಎನರ್ಜಿ ಬೇಕಲ್ಲ, ಅವೆಲ್ಲ ಎನರ್ಜಿ that also in the gaseous state. Gaseous state ಅಂದ್ರೆ ಏನು? ಫುಲ್ ಸ್ಟ್ರಾಂಗ್ ರಿಲೇಶನ್ಶಿಪ್ ಇದೆ. ಗ್ಯಾಸಿಯಸ್ ಸ್ಟೇಟ್ ಅಂದ್ರೆ ಫುಲ್ ಸ್ಟ್ರಾಂಗ್ ರಿಲೇಶನ್ಶಿಪ್ ಇದೆ. ಅದನ್ನ ಬ್ರೇಕ್ ಮಾಡ್ಲಿಕ್ಕೆ ಯಾವ ತರ ಎನರ್ಜಿ ಬೇಕಲ್ಲ ಅದಕ್ಕೇನ್ ಕರೀತಾರೆ? ಬಾಂಡ್ ಎನರ್ಜಿ ಆರ್ ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್. ಕ್ಲಿಯರ್? ಬಾಂಡ್ ಎನರ್ಜಿ ಆರ್ bond strength. Now the same amount of energy is being realized in the formation of the 1 mole of a particular bond. 1 mole of a particular bond. Clear? So now clear with the definitions of bond length, bond energy or also bond strength. Clear? Next comes what? Hybridization. Okay, so before we start with the hybridization, we are going to take a 10 minutes break. So I'll be back in 10 minutes. Till then you people need to be here itself. Don't run anywhere and go. So we will be back in 10 minutes. Till then, understand the concepts properly. How much I have taught you. Hope so you are making up your notes also. So notes ಮಾಡ್ಕೊಂಡು ಕಲಿತಿದ್ರೆ ಅಂದ್ರೆ ಸ್ವಲ್ಪ ಚೆನ್ನಾಗಿ ಕುಂತು ನೋಡಿ ಆಯ್ತಾ. Till then I'll be back. Yes, let's start then. Let's resume the class. I'm audible and visible properly to everyone now. I'm audible and visible properly to everyone. Yes, let's start the class. So ಎಲ್ಲಿ ಸ್ಟಾಪ್ ಮಾಡಿದ್ದೆ? ಎಲ್ಲಿ ಸ್ಟಾಪ್ ಆಗಿತ್ತು ಕ್ಲಾಸು? ಮ್ಯಾಮ್ 10 minutes ಅಂತ ಜಲ್ದಿ ಬಂದ್ಬಿಟ್ರಾ? ಎಸ್ ಜಲ್ದಿ ಬಂದ್ಬಿಟ್ಟಪ್ಪ, ಮುಗಿಸ್ಬೇಕಲ್ಲ ಚಾಟ್ ಕ್ಲಾಸು. ನೆಕ್ಸ್ಟ್, okay, let's start with the hybridization now. So hybridization ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್. ಓಕೆ, ಹೈಬ್ರಿಡೈಸೇಷನ್ ಮೇಲೇನು ಬಹಳ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ ಆಯ್ತಾ. ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್. ಓಕೆ, ಸಾರಿ ಅಣ್ಣ ಅವಾಗಲೇ ಅಂತ ಇಮೋಜಿ ಹಾಕು ಮ್ಯಾಮ್, ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿ ಆ್ಯಂಡ್ ಕ್ವಶನ್ ಮಾಡಿ. ಕ್ವಶನ್ಸ್ ಅನ್ನೋನು ಮಾಡ್ತೇನಪ್ಪ. ಒನ್ಸ್ ದ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಇಸ್ ಡನ್, ಕ್ವಶನ್ಸ್ ಆರ್ ಆಲ್ಸೋ ಬೀನ್ ಟೇಕನ್. ಸೊ ಎಷ್ಟು ಮಂದಿ ಎಷ್ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡು ಚಾಪ್ಟರ್ಸನ್ನು ಹೇಗೆ ಕ್ವಶನ್ ಸಾಲ್ವ್ ಮಾಡ್ತಾರೆ ಅನ್ನೋದು ಚೆಕ್ ಮಾಡೋಣ ಆಯಿತಾ. Let's start hybridization. The mixing of the dissimilar orbital of the similar energies. Dissimilar orbital the complete agi similar energies anna hege form martevalla to form the new set of hybrid orbital. New set of hybrid orbital na form martide. Okay, like number of the hybrid orbitals is been formed is equal to the number of orbitals taking part in the hybridization. So ಯಾವ ತರ number of hybrid orbitals is forming, hybrid orbitals in form ಆಗ್ತಿದೆ ಅಲ್ಲ, ಅದು equal to the number of orbitals which is taking part, it is taking part in the hybridization, which is taking part in the hybridization. Next comes what, depending upon the different combinations of sp orbitals, depending on the combination of the sp orbitals, these types of hybridizations are known. So this type of hybridizations are, we are going to understand it. First is sp3 hybridization. In this case, s and 3p orbitals hybridize to form what? 4 sp3 hybrid orbitals. So these 4 sp3 hybrid orbitals are being oriented in the tetrahedral arrangement. ಯಾವ ತರ arrangement ಇರುತ್ತೆ? If in case 4 sp3 orbitals ಇದ್ರೆ, the arrangement will be in the form of a tetrahedral. The arrangement will be in the form of what? Tetrahedral. Clear? Next, sp3 hybridization ನಲ್ಲಿ ಇದು understood sp3 hybridization ಅಂದ್ರೆ sp3 hybridization ಅಂದ್ರೆ tetrahedral arrangement ಇರುತ್ತೆ. ಕ್ಲಿಯರಾ? ನೆಕ್ಸ್ಟ್ sp2 hybridization. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಬಿಟ್ವೀನ್ ದ 1s orbital with the 2p hybridization. Okay, 2p elements ಇರುತ್ತೆ. Okay, 2p orbitals mix together to form a sp2 hybrid orbitals, and the orientated is going to be what? Means the geometry is going to be the trigonal planar geometry. It's going to be what? Trigonal planar geometry. Clear? Trigonal planar geometry ಅಂದ್ರೆ ಏನು? sp2 hybridization ಅಂದ್ರೆ ಏನು? In this case, 1s and 2p orbitals will mix together. ತಿಳಿತಾ? ಸೊ ಅವಾಗ ಒಂದು s ಮತ್ತೆ 2p ಯಾವಾಗ ಕಂಬೈನ್ ಆಗುತ್ತಲ್ಲ, ಅವಾಗ trigonal bipyramidal is going to be forming. Clear? Next, this is how it's been forming. Simple example, one s orbital ಇದೆ, 3p orbitals ಇದೆ, combine ಮಾಡುತ್ತೆ ಈ ತರ to form what? sp2 orbitals, or one unchanged p orbital is going to be forming. Why one unchanged? Why? Because we have only 3p orbitals. Okay, ಮೂರು ಅಷ್ಟೇ ಇರುತ್ತೆ, ಅದು ಸಲ ಮೂರು ಜೊತೆ ಅಷ್ಟೇ ಕನೆಕ್ಟ್ ಆಗೋದು, ಇನ್ನೊಂದು ಹೇಗಿರುತ್ತೆ ಅದೇ ತರ ಇರುತ್ತೆ. For that purpose it's going to form what? Trigonal planar geometry. Okay, trigonal planar geometry ata form ಆಗುತ್ತೆ structure. Next comes what? The remaining p orbitals, if required, form sideways overlapping with the other unhybridized p orbital of a other C atom and leads to the formation of P2C double bond CH2 bond has in the hydrogen. Clear? Has in the hydrogen. Next comes what? sp hybridization. How the sp hybridization is going to form? Concentrate. This is also very important. Now in this case, 1s orbital will combine with 1p orbital mixture together to form 2 sp hybrid orbitals and are oriented in the linear shape. It's oriented in the linear shape. Straight agirutte. Complete it will be straight. Okay. So 1s orbital, it is combined with the 3p orbitals to form 2 sp orbitals and 2 unchanged p orbitals will be remaining. Clear? So for that purpose, it will be linear geometry. So it will be how much? What it will be? Will be linear geometry. Clear? Linear geometry irutte. Yes. Next, the remaining 2 unhybridized p orbitals overlap with another unhybridized p orbital, leading to the formation of a triple bond has in like CH triple bond CH. Okay, CH triple bond CH ಹೇಗೆ ತರ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ಇಲ್ಲೊಂಥರ ಈಸಿ ವೇ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಓಕೆ, ಬಾಕ್ಸ್ ತರ ಇದೆ, ಸೊ ದಟ್ ಇಟ್ ವಿಲ್ ನಾಟ್ ಬಿ ಕಾನ್ಸೆಪ್ಷನಲ್. ಮೀನ್ಸ್ ಏನೋ ಥಿಯರಿ ತರ ಓದ್ಕೊಂತ ಹೋದ್ರೆ ಈಸಿಯಾಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗಲ್ಲ. ಮೀನ್ಸ್ ನಾವು ಇನ್ ಬಾಕ್ಸ್ ವೈಸ್ ಇಫ್ ಇಟ್ ಟೆಲ್ ಇಟ್ ವಿಲ್ ಬಿ ವೆರಿ ಈಸಿ. ಓಕೆ, it's okay sis. ಯಾರಿಗಪ್ಪ ಸಿಸ್ಸು? Yes, hybridization considered mildly. Hybridization, if in case it's having a sp, then the total number of orbitals which is taking part is 2. Okay, ಎಷ್ಟು orbitals take part ಆಗ್ತಿದೆ? 2 orbitals participate ಮಾಡ್ತಿದೆ hybridization ನಲ್ಲಿ. ಒಂದು s, one more p. Shape ಯಾವ್ದಿದೆ? Linear ಇರುತ್ತೆ. ತಿಳಿತಾ? Example which we can give it as what? This is the example, pi bond and the sigma bond. Clear? Next comes sp2. Pi bond single sigma bond ಅಂದ್ರೆ ಗೊತ್ತಿದೆ ನಿಮಗೆ already. Pi bond ಅಂದ್ರೆ head to head, sidewise or straight overlapping, lateral overlapping is all called as a pi, and if in case head to head is there, then it is all called as a sigma one. Clear? So one sigma ಆಗ್ತಿದೆ, one ಎರಡು pi ಆಗ್ತಿದೆ. ಈ ತರ ನೆನಪಿಟ್ಕೋಬಹುದು ಆಯ್ತಾ. Next comes what? sp2. sp2 is having total number of orbitals taking part is 3. ಎರಡು p ಇದೆ, one s ಇದೆ ಆಯ್ತಾ. So 1 is s and 2 is p, and the shape is going to be the trigonal planar. This is how the formation is going to form. This is the 2 pi bonds which is going to be forming. Means lateral or sidewise overlapping is happening in between both the compounds or both the elements. Clear? Next comes the sp3. What is the meaning of sp3 hybridization? sp3 hybridization, total number of orbitals which is taking part is 4. Okay, 4 orbital participate ಮಾಡುತ್ತೆ. 1 is s and 3 are p orbitals. More p orbitals ಇರುತ್ತೆ, 1 s orbital ಇದೆ ಆಯ್ತಾ. So the shape is going to be what? Tetrahedral is the shape of the element. Now next comes what? Example. So this is the example how it's going to be forming. ಎಲ್ಲ sigma ಇದೆ because all are forming singly. Okay. Next sp3d. Okay, sp3d ನಲ್ಲಿ 5 ಒಂದು s, 3 p ಮತ್ತೆ ಒಂದು d. So one is s, 3p and one is d. Clear? So that is going to be the 5 and it is going to be the trigonal bipyramidal. ಅದಕ್ಕೆ ಏನು ಕರೀತಾರೆ? trigonal bipyramidal ಅಂತ ಕರೀತಾರೆ. Next comes sp3d2. So don't worry about the shape. Always they will not tell you people to draw the shapes. Okay, ಯಾವಾಗಲೂ shapes ಅನ್ನು draw ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಲ್ಲ. They will most probably ask the hybridization and they will ask the shape of it. Okay, hybridization ಮತ್ತೆ shape ಜಾಸ್ತಿ ಕೇಳ್ತಾರೆ. They will not ask much about drawing the shapes. Shapes ಕೇಳ್ತಾರೆ, draw ಮಾಡಂತ ಹೇಳ್ತಾರೆ, but it's rarely asked. Okay. Next comes what? sp3d2, that is 6, that is 1 s, 3 p ಮತ್ತೆ 2 d electrons ಇದೆ. Sorry ma'am, I will leave. Why you are leaving, Chinni? So 6 electrons are there, 1 is s, 3 is p and 2 is d. So this is going to be the octahedral and this is the structure how it's going to be forming. Krita, how it has been forming? How it's been of PCl5. Yes, we can give PCl5 also. Very good. This is called PCl5 only. Okay. Next, so bond characters. Now you understood what is the meaning of a bond length, bond strength. So these all things that we will learn it in detail now. That also we learned it in detail, more detail way. Bond length ಅಂದ್ರೆ ಏನು? The distance between the nuclei of the atom. So the nuclei ಏನಿದೆ ಅಲ್ಲ ಇದರದು, these are the nuclei. Okay, This distance which is there, this is called as a bond length, and it is being expressed in the angstrom, that is A naught units of a picometer. Unit is going to be the picometer, and it is going to be expressed in the form of angstrom. It is going to be participated in the form of angstrom. Now the bond length is the ionic compound, that is Rc plus Ra, and next comes the bond length is a covalent compound, that is AB, that is Ra plus Rb. Ivaglu covalent bonding agutte. Clear? Next comes important features of bond length. Important features of the bond length are which? Bond length is any important features ide. Okay. So first is the bond length of the homonuclear diatomic molecules are twice the covalent radii. First option is what? First point is what? Homonuclear diatomic molecules. Homonuclear diatomic molecules are twice, means double the covalent radii. Okay. It's double the covalent radii. Ma'am, the rate law for any reaction cannot be determined experimentally. It can be experimentally detected, Amma. Okay. So consider it properly. At last, we are going to solve the questions also. I want everyone to answer those questions. Okay. So every question, I'll be giving 30 seconds to 40 seconds to sit and think and then answer it. Okay. So now second is what? The length of the double bonds are less than the length of the single bonds between the same two atoms, and the triple bonds are even shorter. Triple bonds are more shorter, okay? And the double bonds and the single bond is more greater than the double bond is more greater than the triple bond. Mande triple bond elakita kadame short irutte. Short triple bond and takshana double bond barutte, double bond and takshana single bond barutte. Aita? So that is called as decreasing bond length. That is called as what? Decreasing bond length. Okay. Now bond length decreases with increase in the S character. So yav tara increase aguttala S character du avaga bond length increase akont hogutte. The increase of the bond length is depends on the S character. Since S orbital is smaller than a p orbital, as we know that S is smaller than the p orbital, according to that, how much the angstrom it will be? This is going to be sp3 andre eno CH bond is between 1.112 angstrom. So sp2CH andre 1.103 angstrom. sp andre CH, that is 1.08 angstrom. Clear? So this is how you people need to understand. Means what? 25% S character ಇದೆ. ಆಮೇಲೆ 33.3% of S character has in alkenes. Alkenes ನಲ್ಲಿ ಎಷ್ಟು percentage S ಇರುತ್ತೆ? 33.3% ಇರುತ್ತೆ. ಆಯ್ತಾ? Next 50% of S character has in the alkynes. 60% alkynes ನಲ್ಲಿ ಇರುತ್ತೆ. Clear? Next, bond length of the polar bond is smaller than the theoretical non-polar bond. Okay. So bond length polar bond is small irutte. Polar bond ಚಿಕ್ಕದ ಇರುತ್ತೆ. ಅದಕ್ಕಿಂತ non-polar bond ಜಾಸ್ತಿ ಇರುತ್ತೆ bond length. Why? Because it's theoretical. Theoretical non-polar ಅಂದ್ರೆ theoretical way we will find it for that purpose. Okay. Clear? Next comes bond angle. Bond and length is done. Now let us understand about the bond angle, how we need to calculate it. Now bond angle is the angle between the two adjacent bonds of an atom in a molecule made up of 3 or more atoms. It's made up of how much? 3 or more atoms it is made up. Now how the bond angles mainly depend? It depends on the following 3 factors. Which are these 3 factors? It depends on the hybridization. Yav tara hybridization ide adar mele depend agutte bond angle. Aita? So the bond angle depends on the state of the hybridization the central atom is. So central atom yav position illide, yav tara connect agide different elements jode adar mele depend agutte angle. Okay. So niಮಗೆ ಗೊತ್ತಿರಬೇಕು ನಾವು ಯಾವ ತರ ನಿಲ್ತೇವೆ. Right now I am standing in the middle of the class, right? So class ಇದು in the middle ನಿಂತಿದ್ದೇನೆ ನಾನು. It means what? I am like 360 degree ನಲ್ಲಿ ಇದ್ದೇನೆ. ಆಯ್ತಾ? ಸೇಮ್ ಅದೇ ತರ ಇಲ್ಲಿನು depends on which position the central atom is. So central atom ಯಾವ position ಇರುತ್ತಲ್ಲ ಅದರ ಪ್ರಕಾರ bond angle decide ಆಗುತ್ತೆ. Clear? First one is sp3. Okay, one example ತಗೊಳ್ಳೋಣ. That is sp3 hybridization. So bond angle of this is what? Central metal atom ಏನಿದೆಯಲ್ಲ S ಮೂರು p ಜೊತೆ ಯಾವ angle ನಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗಿದೆ? It's being connected at a 109 degree 28 minute. Okay, 109 degree 28 minute. Example we can give it as CH4. Okay, example ಯಾವ್ದು ತಗೋಬಹುದು? CH4. C is the central atom. CH4 ಇದೆಲ್ಲ ಹೈಡ್ರೋಜನ್ಸ್. So now what is the bond angle between them? Bond angle is 109 degree 28 minute. So we will tell it as in this way. Clear? This is the bond angle between them. Understood? Now sp2. Bond angle is 120 degree and the example is going to be what? BCl3. The example is going to be the BCl3. Next comes the hybridization sp and the bond angle is going to be the 180 degree and the example we can take it as BeCl2. Example ಯಾವ್ದು ಕೊಡಬಹುದು? BeCl2. Clear? According to that, we can draw the structures. So ಒಂದ್ಸಲ angle ಗೊತ್ತಾತಂದ್ರೆ structure ಮಾಡ್ಲಿಕ್ಕೆ easy ಆಗುತ್ತೆ. So structure ಮಾಡ್ಲಿಕ್ಕೆ bond angle ಗೊತ್ತಿರಬೇಕು. They will not tell you that exactly you should take the bond angle. So ಎಲ್ಲ protector ತಗೊಂಡು full draw ಮಾಡ್ಬೇಕಂತ ಏನೂ ಇಲ್ಲ. They will be there. Okay, ಅದು ಇರುತ್ತೆ actually protector use ಮಾಡ್ಕೊಂಡು, but ನಿಮಗಿರಲ್ಲ ಅದು, ಆಯ್ತಾ? Next comes what? Yeah, so generally S character increases in the hybrid bond and the bond angle increases. So bond angle ಹೇಗೆ increase ಆಗುತ್ತೆ? If in case the S character is increasing, then the hybrid bond and the bond angle is also going to increase. Clear? Next, lone pair repulsion. What is the meaning of a lone pair repulsion? If the bond angle is being affected by the presence of the lone pair of the electrons at the central atom, the lone pair of electrons at the central atom always try to repel the shared pair. It will always to repel with the shared pair. Okay, and due to this, the bonds are displaced slightly inside the resulting in the decrease of the bond angle. Clear? Now let's go to the electronegativity. If the electronegativity of the central atom decreases, bond angle also decreases. So electronegativity decrease ಆಕೊಂತ ಹೋದ್ರೆ bond angle decrease ಆಕೊಂತ ಹೋಗುತ್ತೆ. ಯಾಕೆ? Because of electronegativity. ತಗೋತಿದೆ ಅಪ್ಪ electron, it means what is moving more over. Right? So for that purpose only, the bond angle is going to start decreasing. Clear? Next comes the bond energy or bond strength. So this also we have learnt it. Let's be quick now to understand it. The amount of the energy required to break the bond in molecule is called as bond energy. It means what? ನಾನು ಯಾವುದೋ ಒಂದು electron ತಗೋತಿದ್ದೇನಪ್ಪ. I'm taking NaCl are the best friends right now. Okay, I'm taking electron from the sodium right now. It means what? I'm breaking the bond there. To break that bond, what energy I needed, that is called as bond energy or bond strength. Clear? Now, the bond energy is the sigma bond is more than that of the pi bond. Most probably, the bond energy will be the sigma bond itself compared to the pi bond. Why? Because there will be always be a head-to-head overlapping. Okay? Now, head hinge idkond full like idan martane. Aita? Next comes what? The bond energy decreases with increase in the number of the lone pairs of the bonded atom. So always it's like what? S is lesser than the P, P is lesser than the SP, lesser than the SP2, lesser than the SP3. Clear? Understanding? Thumbs up in the chat box fast. Next comes the MOT, that is also called as molecular orbital theory. Next comes what? Molecular orbital theory. Clear? Let's start with the molecular orbital theory. First point is molecular orbitals are formed by linear combination of atomic orbit. So, MOT form agutte, it has been formed by linear combination of atomic orbit. Linear combination of atomic orbit. Okay. Why Darshan late to the class? So atomic orbit of all the atoms are assumed to be interfere with each other in the form of a waves. So in the form of a waves only, the atomic orbital of all the atoms is going to be interfering. Means what? It is interfering to form the MOT. Okay, molecular orbital theory form ಆಗ್ತಿದೆ. Next, bonding molecular orbital are formed by construction interference of the atomic orbital. Construction interference of the atomic orbital. Clear? Next, anti-bonding orbital are formed by destructive interference of the atomic orbital. So ಯಾವಾಗ anti-bonding ಆಗುತ್ತೆ, ಯಾವಾಗ distraction ಆಗುತ್ತಲ್ಲ, ಅವಾಗೆಲ್ಲ anti-bonding form ಆಗುತ್ತೆ. Most of the cases it will be forming only anti-bonding. Okay, it depends on the example actually. We'll see the examples also. Okay. Now anti-bonding of a molecular orbital is of higher energy than the bonding molecular orbital. Okay. So anti-bonding do ಜಾಸ್ತಿ energy ಇರುತ್ತೆ bonding ಗಿಂತ. So bonding first ಆಗೋದು actually bonding molecular orbital. Okay, bonding molecular orbital ಆದ ತಕ್ಷಣ anti-bonding ಆಗುತ್ತೆ. So it's actually like that where anti-bonding is having more energy compared to the bonding molecular orbital. Clear? Next, in simple homonuclear diatomic molecule, the order of the MOs, that is molecular orbitals, is based on increasing energy is. So it's in the form of increasing energy here itself, like how the sigma bond means what, head to head overlapping is happening, pi bond is means what, side to side overlapping is happening, right? So this is how it's been forming. Now for the molecules including O2 and above the order is going to be what? That is alpha 1s, alpha star, that is anti-bonding is happening. Then alpha S2, bonding is happening. Then the anti-bonding, bonding, anti-bonding, bonding, anti-bonding. If it is having a star at the head, that is all called as what? That is all called as anti-bonding. Yellow star irutte adukku anti-bonding anta karitare. But anti-bonding strong irutte bonding ginta. Aita. Next comes the bond order. So bond order definition in barutte. Bond order is actually equal to the half the number of bonding electrons, ಎಷ್ಟು bonding electrons ಆಗಿದೆ, minus the number of anti-bonding electrons. How you are going to find the bond order? Bond order is actually equal to the half the number of bonding electrons minus the number of bonding electrons. Sorry. Yes, anti-bonding electrons. Anti-bonding electrons. Clear? Now next comes the application of MOT to the homonuclear diatomic molecules. Okay. Homolytic dimolecules. Clear? Okay, just give me 2 minutes. Okay, so in application of MO2 to MOT, that is molecular orbital theory, to the homonuclear diatomic molecules are first in column ಕೊಟ್ಟಿದ್ದಾರೆ, species ಕೊಟ್ಟಿದ್ದಾರೆ, means examples ಕೊಟ್ಟಿದ್ದಾರೆ. Next comes the total number of the electrons, total number of the electrons. What organic class ಗೆ Diksha ma'am ಹೇಳಿ please. Who is Diksha ma'am? Okay. Now total number of electrons, so next electronic configuration, then the bond order, then the magnetic behavior. Okay. Now a species nalli H2 plus ತಗೊಂಡಿದ್ದೇವೆ. Total number of electrons are how many? 1 electron is there. Okay. Next comes the electronic configuration. What is that? 1s2. Okay. Electronic configuration ಏನಾಗುತ್ತೆ? 1s2. Then the bond order is going to be what? Now bond order ಅಂದ್ರೆ ಏನು? ಈಗ just definition ಕಲ್ತ್ವಿ. What is the bond order? So bond order is half the number of bonding electrons. ಯಾವ ತರ bonding electrons ಇದೆ? 1 ಇದೆ. Minus it is going to be number of anti-bonding electrons. Anti-bonding electrons 0 ಇದೆ. Okay. Divided by 2. It's going to be the half. Half means what? Magnetic behavior is going to be what? Paramagnetic. Paramagnetic will be the, now paramagnetic will be the magnetic behavior. Clear? Next again comes the H2, that is total number of electrons is going to be the 2 again. Then the electronic configuration is going to be the NS2 and the bond order is going to be what? 2 are the bonding order minus 0, that will be divided by 2 will be 1. 1 andre ಏನು? Diamagnetic. Any magnetic which is having single, that is called as diamagnetic. Next comes the helium, that is 3. Same again, here the 3 bonds are being formed. So that is the electronic configuration according to the molecular orbital orbital theory, according to the molecular orbital theory, this is the electronic configuration. I'm not going to explain you people MOT completely. Why? Because that will not help you people in the NEET. It will be only helping you people for the board's purpose. So we are going to take a NEET class today. So we are going to just understand how it's been getting formed. Okay. So ಇಲ್ಲಿ antibonding bonding ಯಾವುದು ಎಷ್ಟು ಇದೆ 2 ಇದೆ, antibonding 1 ಇದೆ ಇಲ್ಲಿ. You can just observe here the one which is present here. This is having 1, so I'm adding it is 1. 2 minus 1 divided by 2, it will be half. So again it will be a paramagnetic. Again it will be a paramagnetic. Next comes the helium, that is going to be the total number of electrons going to be 4. And here the electronic configuration, again it will be more, antibondings are 2, so I have added it as 2. It will be molecule does not exist itself. Such type of things will not even exist. Next comes the O2, that is 16. So how the 16 will be formed here? They have written it electronic configuration. So 10 are the bonding irutte, 6 anti-bonding ide. So divided by 6, 10 minus 6 is how much? 4. 4 divided by 2 is going to be the 2. It means what? Paramagnetic. Here paramagnetic. Okay, done. Next, same application of MOT to the heteronuclear diatomic molecule. If in case it's having a heteromolecular diatomic molecule. Okay, now molecules or ions, that is CO, total number of electrons are going to be how much? 14. Yes, the total number of electrons 14 irutte. Next comes what? Magnetic behavior. It's going to be the diamagnetic. If in case this is having a NO as an example and it is having total number of electrons as a 15, then it is going to be the paramagnetic. Odd almost paramagnetic irutte. Okay, odd numbers. So NO plus 14 diamagnetic. So 16 diamagnetic, Cn 13 paramagnetic, Cn minus 14 diamagnetic. It means what? If it is not having a paired electrons illa andre, you just think it like it is a paramagnetic. If it is having a paired electrons, you think it has a diamagnetic. Clear? Next comes the simple example, that is formation of a bonding of a alpha and anti-bonding. Okay, ಹೇಗೆ formation ಆಗುತ್ತೆ bonding ಮತ್ತೆ anti-bonding ದನ್ನ explain ಮಾಡ್ತೇನೆ ನೋಡಿ, ಚೆನ್ನಾಗಿ ನೋಡ್ಕೊಳ್ಳಿ ಇಲ್ಲಿ. So this is how the formations are going to happen. If in case the stars are present, then it is called as anti-bonding. Stars ಇಲ್ಲ ಅಂದ್ರೆ bonding. ಆಯ್ತಾ? Now this is a molecular structure for the linear combination of atomic orbitals of alpha A and alpha B centered on the two atoms A and B respectively. Clear? ಇಲ್ಲಿ A ಇದೆ, ಇಲ್ಲಿ B ಇದೆ. Dana. So ಇಲ್ಲಿ ಒಂದು electron transfer ಆಯ್ತು, ಇನ್ನೊಂದು electron ಇಲ್ಲಿ ಹೋಯ್ತು. So ಎರಡರದ್ದು electron ಇಲ್ಲಿ ಒಂದು pair ಆಗಿಬಿಡ್ತು. ಆಯ್ತಾ? So this is how the bonding orbital lower energy than that of the atomic orbitals has been forming. Now anti-bonding ನಲ್ಲಿ ಏನಾಗುತ್ತಪ್ಪ? Anti-bonding there are no electrons to be transferred. So there is 0. For that purpose, it's going to be the linear. Some cases, it's like what? There will be having an anti-bonding, which we need to upload it here. Means it'll hackback now. Aita? It'll anti-bonding hackback. Clear? Next comes types of molecular orbitals. Types of molecular orbital nalli. Molecular orbitals of diatomic molecules are designed as a sigma, pi and delta. How it's been described? First one is going to be the sigma. Second one is going to be the pi. And third one is going to be what? Delta. Clear? So these are the three designated molecular orbitals. Now in this nomenclature, the sigma molecular of the orbitals are symmetrical around the bond axis, while the pi molecular orbitals are not symmetrical. Means p orbitals which are present, means pi orbitals which are present, non-symmetrical agirutte. They will be non-symmetrical. Okay, they will be non-symmetrical. Sigma ಏನಿರುತ್ತೆ? Symmetrical ಆಗಿರುತ್ತೆ. Clear? Next, for example, the linear combination of 1s orbital is centered on the two nuclei produces two molecular orbitals, which is going to be the molecular orbital of the sigma type and are designated as a alpha, means sigma 1s and sigma star 1s, means anti-bonding ಆಗ್ತಿದೆ ಆಯ್ತಾ? So that is going to be the, if in case the internucleus axis is taken to be the z direction, then it can be seen that linear combination of this 2p z orbitals of two atoms also will produce the 2 sigma molecular orbitals. 2 sigma molecular orbitals is going to be formed. Means what? It's been designated. Okay. Designated as what? Alpha 2b and alpha 2p star. So that is alpha 2 star 2p. Okay. That is going to be the how you people need to understand about the pi and the sigma bonds. Okay. Next comes molecular orbitals are obtained from the 2px and 2py. Orbitals are not symmetrical around the bond axis because of the presence of the positive lobes above and negative lobes below the molecular plane. Such molecular orbitals are labeled as pi and pi star. It's been labeled as what? Pi and the pi star. Clear? So that is going to be what? A pi bonding MO has the larger electron density above and below the internuclear axis. So the pi star antibonding molecular orbit has the node between the nuclei. Pi star again node irutte. Pi star again node irutte. Clear? Types of molecular orbitals theta, alpha, pi and delta. Clear? So this is how the structures are going to form. Concentrate properly. First one they have given it here. Same way 1s, pi 1s form ಆಗುತ್ತೆ. ಇಲ್ಲಿ 2pa, 2pb and it is going to form sigma 2p. Okay, p2d. Same way last one. ಆಯ್ತಾ? Next comes what? Hydrogen bonding. So and its caution of the formation of hydrogen bonding. Okay. Yes. So nitrogen, oxygen and the fluorine are the highly electronegative elements. So when they are connected or attracted to the hydrogen atom to form a covalent bond, the electrons of the covalent bond are shifted towards the more electronegative atom. More electronegative atom andre enu? In a case, okay, hi, hello. So in a case, okay. ನಾವು ಯಾವುದೊಂದು ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ಮಾಡ್ತಿದ್ದೇವೆ. ಎಕ್ಸಾಂಪಲ್ ಯಾವುದಾದ್ರೂ ಒಂದು ಫ್ಲೋರಿನೋ ಆಕ್ಸಿಜನ್ ಇಲ್ಲ ನೈಟ್ರೋಜನ್ ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಬಿಡಿ ಆಯ್ತಾ. ಸೊ ಯಾವಾಗ ಬಾಂಡ್ ಫಾರ್ಮೇಶನ್ ಮಾಡ್ತಿದ್ದೇವಲ್ಲ ಆ ಟೈಮ್ನಲ್ಲಿ ದೇ ಆರ್ ಅಟ್ಯಾಚ್ಡ್ ಟು ದ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಟು ಫಾರ್ಮ್ ದ ಕೋವಲೆಂಟ್ ಬಾಂಡ್. ಓಕೆ, ಟು ಫಾರ್ಮ್ ವಾಟ್ ಕೋವಲೆಂಟ್ ಮೀನ್ಸ್ ಇಟ್ಸ್ ಆಕ್ಚುಲಿ ಲೈಕ್ ಕೋವಲೆಂಟ್ ಇಸ್ ವೆರಿ ಮಚ್ ಲೈಕ್ biggest process, okay, to happen first of all. Okay, so adanu shift ಮಾಡ್ಕೊಂತ ಹೋಗುತ್ತೆ. slowly it will shift the electrons. Okay, slowly it will shift the electrons. Means choice of the things will slowly decrease. It's not like suddenly it will happen same like ionic bonding. Ionic ನಲ್ಲಿ ಏನಾಗುತ್ತೆ ಸಡನ್ ಆಗಿ ಆಗುತ್ತೆ, choices change. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಕೋವಲೆಂಟ್ ನಲ್ಲಿ ಸ್ವಲ್ಪ ಸ್ಲೋ process. Okay, this partial positively with the help of the other more electronegative atom, and this bond is known as what? Hydrogen bond, and is weaker than the covalent bond. Okay, and so it's weaker than the covalent. First comes the ionic, then comes the covalent, then after that it comes the hydrogen bonding. Okay, then the hydrogen, for example HF molecule, the hydrogen bond exists between the hydrogen atom of one molecule and the fluorine atom of another molecule has depicted below. So this is how the formation is going to happen. Means it's take time, gap will be more. Okay, now here the hydrogen bond acts as a bridge between the two atoms of which holds the one atom by the covalent bond. This is how the covalent bonding is happening, and the other by the hydrogen bond. So this is how the hydrogen bonding is happening. Hydrogen bonding. Clear? Then the hydrogen bond is represented by the dotted line. So ಈಗ ನಾವು ಕೋವಲೆಂಟ್ ಬಾಂಡಿಂಗ್ ಸಿಂಗಲ್ ಬಾಂಡು ಅಂದ್ರೆ ಇನ್ ಕೇಸ್ 2 ಪೇರ್ಸ್ ಇದ್ರೆ ಡಬಲ್ ಬಾಂಡ್ ಆಗುತ್ತೆ, ಟ್ರಿಪಲ್ ಬಾಂಡ್ ಆಗುತ್ತೆ, ಅದೆಲ್ಲ ಗೊತ್ತಾಯ್ತು. ಯಾವ ತರ ಫಾರ್ಮ್ ಮಾಡ್ತೇವೆ? ಒಂದು ಸಿಂಗಲ್ ಲೈನ್ ಡ್ರಾ ಮಾಡ್ತೇವೆ. ಬಟ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ಹೇಗೆ ಫಾರ್ಮ್ ಮಾಡ್ತೇವೆ? ಇಟ್ ಇಸ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಅ ಡಾಟ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್. ಓಕೆ, ಡಾಟ್ ಆಗಿ ಹಿಂಗ್ ಡಾಟ್ ಆಗಿ ಫಾರ್ಮ್ ಮಾಡ್ತಾರೆ. This is how the hydrogens will be drawn. While the solid light represents the covalent bond, and thus the hydrogen bond can be defined as attractive force which binds the hydrogen atom of one molecule with the electronegative atom of the another molecule. This is the electronegative atom which will bond with the electronegative atom ide where it went has electrobonding one molecule is it is getting bonded with the electronegative atom. So ivella electronegative atom hydrogen fluorine and nitrogen oxygen ಇವೆಲ್ಲ electronegative element. electronegative element ಜೊತೆ hydrogen bond ಆಗ್ತಿದೆ ಆಯ್ತಾ. And then next comes the causes of the formation of the hydrogen bond, how it will be caused. So when the hydrogen is being bonded to the strongly electronegative element, that is X, the electron pair is being shared between the two atoms which is moves far away. It moves what? Far away far away from the hydrogen atom. As the result, the hydrogen atom becomes highly electropositive with respect to the other atom X. Since there is a displacement of the electrons towards the X, the hydrogen acquires the fractional positive, that is going to be the delta plus, while X attacks the fractional negative. Okay, that is going to be the minus. This is how the formation is going to happen. Then this is a representation which I told you people. Okay, next comes the types of hydrogen bonds. This is the last topic of this concept. So chemical bonding the last topic idu ಏನು types of hydrogen bonding. How we are going to learn the types of hydrogen bonding. After that we have a questions. I will be giving you 40 seconds for each questions. Call your all friends. We are going to have a competition after this. Okay, types of hydrogen bonding nalli ಎರಡು ತರ ಇದೆ. First is intermolecular hydrogen bonding, second is intramolecular hydrogen bonding. First let us learn about the intermolecular. So intermolecular hydrogen bond is, it is formed between the two different molecules of the same or a different compounds. Same or the different compounds between, no, it is formed in between two different elements. Okay, different elements ಇಲ್ಲದ್ರೆ compounds ಜೊತೆ formation ಆಗುತ್ತೆ. Example, H bond in case of HF molecule or alcohol or a water molecule. It means what? Alcohol or water molecule ಜೊತೆನು ಫಾರ್ಮ್ ಆಗಬಹುದು, ಮತ್ತೆ ಹೈಡ್ರೋಜನ್ ಮತ್ತೆ ಫ್ಲೋರಿನ್ ಜೊತೆನು ಫಾರ್ಮ್ ಆಗಬಹುದು. ಆಯ್ತಾ? Next comes the intramolecular hydrogen bond ನಲ್ಲಿ, it is formed between the hydrogen atoms is in between the two highly electronegative. Highly electronegative ಯಾವ್ದೆ? ಫ್ಲೋರಿನ್, ಕ್ಲೋರಿನ್, ನೈಟ್ರೋಜನ್, ಸಾರಿ ಫ್ಲೋರಿನ್, ಆಕ್ಸಿಜನ್, ನೈಟ್ರೋಜನ್. ಓಕೆ, ಇವು ಮೂರು ಏನಿದೆ ಅಲ್ಲ highly electronegative elements. ಆಯ್ತಾ? ಸೊ ಅಲ್ಲಿ ಯಾವಾಗ highly electronegative between the highly electron ಏನಾಗುತ್ತಲ್ಲ ಬಾಂಡ್ ಫಾರ್ಮೇಶನ್, ಅದಕ್ಕೆ ಇಂಟ್ರಾಮಾಲಿಕ್ಯುಲರ್ ಬಾಂಡ್ ಫಾರ್ಮೇಶನ್ ಅಂತ ಕರೀತಾರೆ. ತಿಳಿತಾ? ದ ಟೂ highly electronegative, like example fluorine and oxygen or nitrogen. So atoms present within the same molecule. For example, in O-nitrophenol, the hydrogen is in between the two oxygen atoms. Okay, between the two oxygen atoms. ಇಲ್ಲಿ between hydrogen ಇದೆ, ಎರಡು oxygen atoms ಇದೆ, right? So that is called as intramolecular hydrogen bonding in the O-nitrophenol molecule. Clear everyone? Understood? Till here everyone understood? Yes. Now we are going to completely go to the concept of questions now. So ಈ ತರ questions ನಿಮ್ NEET ನಲ್ಲಿ ಕೇಳಬಹುದು. These are little bit easier questions which I have taken it. So full deep by questions ಮಾಡ್ತೇವೆ. We will do separate PYQs for the chapter wise also. Make sure you people will learn the theory first and then come to understand about the questions. Okay, this is the first question. Every question I'll be going to give you 40 seconds. Make sure you people will think and then answer in the chat box. Okay, which of the following would have a permanent dipole moment? ಯಾವ್ದ್ರಲ್ಲಿ permanent dipole moment ಇರುತ್ತೆ? You people know already what is the meaning of dipole moment, right? Example, 4 options ಕೊಟ್ಟಿದ್ದಾರೆ: BF3, SIF4, SF4 and SEF4. So they have given almost 4 options to you people. Come on, try this everyone. I want everyone to answer in the chat box. Fast, 40 seconds ಕೊಡ್ತೇನೆ. Let's see how many people are going to answer this question. How many people are going to answer this question? Forty seconds for every question. So they have asked about permanent dipole moment. ಯಾವಾಗ permanent dipole moment ಇರುತ್ತೆ? When it is having a net separation of positive and negative charges. When it is having a net formation of positive and negative charges. So ಯಾವಾಗ net formation of positive ಮತ್ತೆ negative charges ಇರುತ್ತಲ್ಲ, positive and negative charges, that time it is called as what? It is having a permanent dipole moment. So we have only one option here, that is going to be the 3, that is SEF4. SEF4 is the element where we have a net charges of positive and the negative charge. Okay, clear everyone? Yes. Let's move to the next question. So ಇನ್ನೊಂದು question ಏನು, the net in the case of alkali metals, the covalent character decreases in the order. So ಯಾವ ತರ covalent character decrease ಆಕೊಂತ ಹೋಗುತ್ತೆ? Come on, tell me. ಯಾವ ತರ net charges decrease ಆಕೊಂತ ಹೋಗುತ್ತೆ? ಯಾವ ತರ decrease ಆಕೊಂತ ಹೋಗುತ್ತೆ? So I will give you people hint also. It's about the Fazan's rule, which we have learnt it already. Fazan's rule ye concept na means people can link the concept to the Fazan's rule. Okay, come on, I'll give you 40 seconds again. Yes, it is related to the Fazan's rule. So what does actually Fazan's rule states us? Fazan's rule tells us that the covalent character increases, then the size of the anion also increases. Size of the anion also increases. Covalent character decrease akonta hodre, size also will be, anions will be increasing. Clear? Anions will be increasing. For that purpose, what will be the answer here? First in barutte, fluorine barutte, right? Fluorine will come first, right? So fluorine is smaller than the chlorine. Chlorine is less than the Br, then the iodine. Now, which is the option which we have? Fluorine, chlorine, bromine and iodine. First option antu illa, second option barlikagalla because they have told fluorine is the highest one here. Not possible. Here the fluorine is there but the chlorine is present. Il Br irbeku, not possible. So only the last option is present, that is option 4. So yav barutte, iodine is greater than the bromine, bromine is greater than the chlorine and the chlorine is greater than the fluorine. Clear? So whenever the covalent character will decrease, the size of the anions will increase. Size of the anions will start increasing. That is called as what? Fazan's rule. It's related to what? Fazan's rule. Clear? Yes, let's move to the next question now. Which of the following two are isostructural? ಯಾವುದು isostructural ಇದೆ? ಯಾವ ಎರಡು compounds isostructural ಇದೆ? First one XeF2 and IF2 minus. Second is NH3 and BF3, CO2 and SiO2 and PCl5 and IF5. Come on, try it everyone. Try it everyone. They have told which are two isostructural. Isostructural andre enu? Come on, I will give you 20 seconds now. Fast, the answers needs to come. So which is going to be the correct option here? PCl5 and IF. No, how it's possible? IF5 ಇದಕ್ಕೆ negative charges ಇಲ್ಲ, positive charges ಕೊಟ್ಟಿಲ್ಲ. ಹೇಗೆ solve ಮಾಡ್ತೀಯ ಅದನ್ನಪ್ಪ? So it will be what? CO2 and SiO2. CO2 and SiO2, because both are going to be the linear one. It's going to be both the linear one. Why? Because carbon is actually having one single bond with oxygen and double bond with one oxygen. So Si also same thing, it's happening. So both are going to be the linear one. They have asked two are isostructural. So these are the two elements or two compounds which is having a isostructural. Clear? Next question. Which of the following species does not exist? Yeah, following species so exist agala. It's very easy. Be2 plus Be2, B2 and N2. Again, I'm going to give you 20 seconds. Fast, because it's easy question, direct question idella adakke. Last question ಸ್ವಲ್ಪ solve ಮಾಡೋದಿತ್ತು. ಈಗ try ಮಾಡಿ. Direct question, they have asked directly. What is the answer? Which of the following is having a which will not exist only? So you need to find with the bond order purpose, okay? ಎಲ್ಲರ್ತದ್ದು bond order form ಮಾಡಿ. ಎತ್ತರದ ಆಗಲ್ಲ. First option is what? They have given Be2 plus. ಎಷ್ಟಾಗುತ್ತೆ bond order? Bond electrons ಎಷ್ಟಿರುತ್ತೆ ಮತ್ತೆ anti bonding ಎಷ್ಟಿರುತ್ತೆ? Bond order deshtiralla means what you people need to find the bond order means anti bonding ಮತ್ತು molecular orbital bonding ಎಷ್ಟು ಆಗುತ್ತೆ ಅನ್ನೋದು ಫೈಂಡ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ if in case bond order is not zero, in case ಯಾವ್ದಾದ್ರು bond order zero ಇಲ್ಲ ಅಂದ್ರೆ that will be the correct answer. So Be2 plus try ಮಾಡಿ, ಆಮೇಲೆ Be2 ಆಮೇಲೆ B2 ಮತ್ತೆ N2 ಎಲ್ಲರಿಗೆ hint ಕೊಟ್ಟೆ. Try everyone, which will be the correct answer. Try ಮಾಡ್ಕೊಂತಿರ್ಬೇಕು. Be2 plus ಏನಾಗುತ್ತೆ? Molecular orbital configuration is going to be what? And electrons bonding electrons ಎಷ್ಟಿದೆ? 4 ಇದೆ. Anti bonding ಎಷ್ಟಿದೆ? 3. Bonding order is going to be means bonding electrons is going to be 3, 4 I think so. Anti bonding 3. So next Be2 ನೋಡಿ ಚೆಕ್ ಮಾಡಿ bond order ಎಷ್ಟಿದೆ? Bond order ಎಷ್ಟಿದೆ Be2 4 and anti bonding also 4. It will be 0 itself here. See, we got the answer here itself. The option B, that is Be2 na ಹೇಳ್ದೆ already. 0 ಯಾವಾಗ ಇರಲ್ಲ ಅವೆಲ್ಲ ಏನು ಕರೀತಾರೆ? That structure, that compound will not be existing itself. Which is having the compound which is not existing, that is going to be what? Be2. Clear? Next question. Which one of the following is not a paramagnetic? ಯಾವ್ದು paramagnetic ಇಲ್ಲ? Paramagnetic ಅಂದ್ರೆ ಏನು? Paired electrons ಇರಬಾರ್ದು ಆಯ್ತಾ? ಸೊ ಯಾವ್ದಿಲ್ಲ ಇದರಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ. NO, N2 plus, CO and O2 minus. We have discussed this. We have discussed this question already. Come on, try it everyone. So ಈ question already discuss ಮಾಡಿದ್ದೇವೆ paramagnetic ಬಗ್ಗೆ. Which is not a paramagnetic. So if it is having one or more unpaired electrons, then it is called as what? Paramagnetic. Right? Come on. First with the NO. Nitrogen and the NO. Nitrogen monoxide nalli eshtiде? The total number of valence electrons are how many? Total number of valence electrons are 11. Right? 11 is having at the NO. N2 plus nalli eshtiದೆ? 9 ಇದೆ. CO nalli eshtiದೆ? ಫಾಸ್ಟ್ ಆಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೇಕು. 9 ಇದೆ, ರೈಟ್? Come on, fast you people need to find the NO, N2 plus ಆಯ್ತು, ಮತ್ತೆ CO ಮತ್ತೆ O2 minus ನಲ್ಲಿ ಎಷ್ಟಿದೆ? Come on. CO ನಲ್ಲಿ ಎಷ್ಟಿದೆ? CO is having how much? 10, right? CO ನಲ್ಲಿ 10 ಆಯ್ತು, ಇಲ್ಲಿ 13 ಆಯ್ತು. Right? It's having how many? 13. Right? So now, pair it. Everything you people need to pair it now. Valence electrons antu gottaytu. Ella pair ಮಾಡ್ಕೊಂಡ್ರೆ ಯಾವುದು odd ಇದೆ? Which is odd? Everyone's are odd. Only one is having even. That is going to be the CO. Simple. Simple. Crystal clear? Yes. Let's move to the next question. In a regular octahedral molecule, mx6, the number of the xmx bonds at 180 degree is. The regular octahedral molecule nalli mx6, the number of xmx bonds at 180 degree anta helidare. So they have asked how much it will be. 3 2 6 4. 3 2 6 4. Come on, try it. This will be your last question. Try, everyone. ಇದು ಈಸಿ ಇದೆ, ಫುಲ್ ಈಸಿ ಇದೆ. ಈ ತರ ಕ್ವಶನ್ಸ್ ಬಹಳ ಕೇಳ್ತಾರೆ. Twenty seconds. So octahedral molecule ಅಂದ್ರೆ ಏನು? Already ಹೇಳಿದರೆ x is 6, right? So it is geometry based on what? Square bipyramidal. ಎಷ್ಟಿರುತ್ತಪ್ಪ? Square bipyramidal. Yes, option C is the correct answer. Square bipyramidal structure ಇರಬೇಕು. Clear? Understood? Yes. So this is all about today's class. ನೀವು maximum ಒಮ್ಮೆ ಟೀಚಿಂಗ್ ಮಾಡಿ ಮಾ. ನೀವು ಮ್ಯಾಕ್ಸ್ ಒಮ್ಮೆ ಟೀಚಿಂಗ್ ಮಾಡಿ ಮ್ಯಾಮ್. ವಾಟ್ ಇಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಒಮ್ಮೆ ಟೀಚಿಂಗ್ ಮಾಡಿ? Okay, so this is all about the today's chapter, that is chemical bonding. So I hope so ಎಲ್ಲರಿಗೂ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗಿದೆ chemical bonding. ನಾ ಯಾವ್ಯಾವ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂತ ಹೇಳಿದೇನಲ್ಲ, ಆ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅನ್ನ ಸ್ವಲ್ಪ ಸ್ಟ್ರೆಸ್ ಮಾಡಿ ಓದಿ. and we have learnt about few questions also today. So separate ಆಗಿ PYQ questions ಮಾಡ್ತೇವೆ, but before that you need to be very crystal clear with the chapter. ಥೇರಿ ಕ್ರಿಸ್ಟಲ್ ಕ್ಲಿಯರ್ ಇದ್ರೆ PYQs ಮಾಡ್ಲಿಕ್ಕೆ ಈಸಿ ಆಗುತ್ತೆ. ಇಟ್ ಮೀನ್ಸ್ ಲೈಕ್ ಮ್ಯಾಮ್ ಥೇರಿ ಕುಂತ ಓದ್ತಾನೆ ಮ್ಯಾಮ್ PYQs ಮಾಡಲಿಲ್ಲ ಅಂದ್ರೆ ನಡೆಯುತ್ತೆ ಅಂತ ಕ್ವಶನ್ ಕೇಳಬೇಡಿ, ಹುಚ್ಚತನ ಅಂತಾರೆ ಅದಕ್ಕೆ, ಆಯ್ತಾ? ಸೊ ಯು ಪೀಪಲ್ ನೀಡ್ ಟು ಡೂ ವಿತ್ ದೋಸ್ ಥಿಂಗ್ಸ್ ಆಲ್ಸೋ. ಬೋತ್ ದ ಥಿಂಗ್ಸ್ ಆರ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಟು ಡೂ. ಸೊ ಎರಡು ತರ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಓಕೆ, ಇಟ್ ವಿಲ್ ಹೆಲ್ಪ್ ಯು ಪೀಪಲ್ ಅ ಲಾಟ್. Clear? So till then, see you everyone for the next class. Bye bye. Make sure you people will be very much consistent with your studies. ಎಷ್ಟು ಕನ್ಸಿಸ್ಟೆನ್ಸ್ ಇರ್ತಾರಲ್ಲ ಅಷ್ಟು ನಿಮಗೆ ಗ್ರೋತ್ ಆಗುತ್ತೆ ನಿಮ್ಮ ಸ್ಟಡೀಸ್ ನಲ್ಲಿ. ಓಕೆ, ಅಂಡ್ ಈವನ್ ಟ್ರೈ ಟು ಸಾಲ್ವ್ ದ PYQs. ಎಷ್ಟು PYQs ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ತಾರಲ್ಲ ಅಷ್ಟು ನಿಮಗೆ ರಿಯಾಲಿಟಿ ಚೆಕ್ ಆಗುತ್ತೆ. ರಿಯಾಲಿಟಿ ಚೆಕ್ ಆಗ್ಬೇಕಂದ್ರೆ PYQs ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ಕೊಂತಿರ್ಬೇಕು ಚಾಪ್ಟರ್ ವೈಸು. ಈಗ ನಾವು ಒಂದು ಚಾಪ್ಟರ್ ಮುಗಿಸಿದೇನಪ್ಪ, ಆ ಥರದ್ದು PYQ ಸಾಲ್ವ್ ಮಾಡ್ಕೊತ್ಕೊಂಡೆ ಯಾವ್ದು ಕುಂತಿದ ತಕ್ಷಣ ಯಾವ PYQs ಬರ್ತಿಲ್ಲ ಆ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅನ್ನ ಇನ್ನೊಂದ್ಸಲ ಓದಿ. ಇದರಿಂದ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ ಪ್ರಿಪ್ರೇಷನ್ ಮಾಡ್ಲಿಕ್ಕೆ, ಆಯ್ತಾ? ಟಿಲ್ ದೆನ್ ಸಿ ಯು ಎವ್ರಿವನ್. ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಟೀಚಿಂಗ್ ಮಾಡಿ ಮ್ಯಾಮ್. ನಾನೇ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಕಲಿಸ್ಬಿಡ್ಲಾ? ಅದನ್ನೂ ಕಲಿಸ್ಬಿಡ್ತೀನಿ ಅಂತ ತಗೊಳ್ಳಿಪ್ಪ, ಆಯ್ತಾ? ಸೊ ಟಿಲ್ ದೆನ್ ಸಿ ಯು ಎವ್ರಿವನ್. ಗುಡ್ ನೈಟ್. ನೋ ಗುಡ್ ನೈಟ್, ಯು ಪೀಪಲ್ ಸಿಟ್ ಅಂಡ್ ಸ್ಟಡಿ ನೌ.